Can you make sure, because we're going to be starting really soon. Thanks. Wow, are we organized? And it's quiet. And it's 9 o'clock. Let's just wait till they get back and see if there are more people who are. Yes, we're pretty much here. Okay. Wonderful. And 9 o'clock. We modelers, right? We AgMIP modelers must be very organized. We're starting completely on time. I'm Cynthia Rosenzweig, for those of you who don't know me or just meeting me for the first time. Welcome to AgMIP10. This is the 10th global workshop that AgMIP has organized. It's very meaningful to have our 10th workshop here at CIMMYT, the home of the Green Revolution. And it's also very significant that we are here in Latin America, because the very first AgMIP multi-crop model intercomparison was done at an AgMIP workshop in Brazil, in Campinas. Is Ken here yet so far? Yes, remember Ken? And remember when the first slide was shown and everybody clapped, and it was comparing, it must have been DISAT and APSIM, yep. So here we are, 15 years later. This is the 10th workshop, but this is 15 years later. Here we are again in Latin America. In that regard, is Geraldo here? Geraldo, is he here? Yes, please stand up. Geraldo is representing, as well as Santiago, representing Embrapa. So thank you so much. And please give our greetings to Eduardo Said, who was the champion of AgMIP in Brazil from the beginning. Okay, let's see. See if we can get this. Yes. Okay, so over to you. Who is here in the room? Let's see, I can't see it now on the screen. It here. Yeah, wait a minute. Okay, here we go. Okay, here we are. Over to you. Who's in the room? Who's in the room and online? There are 175 total participants, over 100 in the room and over 50 online. Welcome to everybody. And we're going to do our very best to make sure that it's a fully hybrid meeting. And so please always remember to engage with the folks who are coming on online. The participants are coming from more than 30 countries. You can see them highlighted in green on the map. So AgMIP is truly a global network. Now, at AgMIP Global Workshops, we always ask this question about old hands of AgMIP and new members and welcome new members. So, who was here at the very first AgMIP workshop? It was in California. Please raise your hands. Okay. So one thing is also once you start an AgMIP, you pretty much keep going. So it's a wonderful network in that regard. Who is here at an AgMIP Global Workshop for the first time? Wow, that's great. Wow, welcome to all new members. And there are, in between 2, 3, 4, 5, 6, 7, 8, 9 folks who have been to many of them. Now, the next thing that we do is we can't go around and do introductions of everybody, which we would like to, but we can't, we don't have time. So now what we do is we ask people to raise their hands for their main field. What's your home field? Because AgMIP is a collaboration across all the fields that we need to truly model and understand all of the different parts of agriculture and the food system. Okay, so here we go. Who considers themselves a climate scientist? Okay, excellent. Go climate. We've always, AgMIP always has had a very, very strong climate component. What about crops? Agronomy, yes. I'm raising my hand. I'm climate. I'm climate and agronomy. I have two hands. How about livestock? Great, great, great. Listen, livestock folks, we need you to help build the livestock component of AgMIP. We've had it through the years. We've done some great projects, but we need more. So please help us on that. All right, here come the gold hats. By the way, each AgMIP hat, sometimes the AgMIP hats all come in different colors. So it's blue for climate and green for crops. And guess what color the economics folks have? Herman is laughing. Herman, what's the color? He's fudging it. They're gold. So who's here from economics? Great. And this is one of the points I'm going to be making again and again, that from the beginning, AgMIP has shared across climate, across physical, biophysical, and socioeconomic, and the economics. Now, what about IT? Yes, please raise your hands. Yes, we need IT more than ever. So we've always have an IT component as well. So that's who's here in the room. All right, now we want to now thank a whole bunch of people. A whole lot of people. First of all, the AgMIP10, this is the organizing committee. We had great calls for weeks and months and months. First, Alex Ruane and Sig Snap were the chairs of the organizing committee. Then the science committee, all the folks there. Thank you very much for your contributions, and really the agenda is the proof of all these great folks' input. And then then the AgMIP coordination unit, who makes it all happen, of course, with Alex and me, but we want to now do a big shout out to Eric and Natalie right there. They're why we're here. Okay. Now, the next thank you is to the sponsors. We thank the Columbia Climate School, still here, Cornell University, Technische Universität München. How's my accent, Herman? Because I was at YASA for a year. Potsdam Institute for Klimat. I'll put it also to pick also in German. The AgMIP World Food Prize Fund, and CIMMIT, of course, and also finally the Global Methane Hub. And Hayden Montgomery will be here later in a couple of days. But I think he's going to be on the panel. Yeah, he's going to be actually here very soon. He's going to be virtual for the panel, and then he's going to be coming later in the week. So thank you to the sponsors. They also are the reason why we're all here. And now we want to, a special thank you to CIMMIT for hosting AgMIP10. We're going to have a video welcome from Bram Govertz. But also, I'm not sure if Daniela has been able to come. Is she here yet? I think she's going to be coming at lunch. But she's Bram's chief of staff. But let's turn now. We're going to have a video welcome from Bram, who is in Spain responding to the challenges of the day.
Good morning, everyone, and welcome to CIMMIT. Welcome to this kickoff plenary of our AgMIP10 workshop themed Responding to Climate Change Urgency. My name is Bram Govertz and I'm the Director General of CIMMIT, and it's my honor to welcome you to our global headquarters on behalf of our entire team and on behalf of the esteemed partners who have done an amazing job organizing this workshop. Unfortunately, I was unable to postpone previously arranged engagements abroad. I'm working very, very hard in this uncertain funding environment to make sure that CIMMYT has the means to continue its important work. So I offer my sincerest apologies for not being with you today in person. However, I do know that our fellow co-organizers and CIMMYT colleagues that participate in this meeting will do everything in their power to make you feel at home and to keep you very busy over the coming days. As you know, we've put together quite an ambitious program covering critical themes in agricultural modeling and climate resilience. And this includes science policy linkages for food systems, technology across scales, model applications in low yielding and low data environments, crop livestock modeling, climate resilience for food and nutrition security, and last but definitely not least, mitigation and adaptation co-benefits and life cycle analysis. We've been very successful actually to bring over 100 of you here together, agricultural modelers, crop modelers, regional economists and global economists, who are all here today to learn from each other and share insights to help advance the agricultural model intercomparison and improvement program, also known as AgMIP. At CIMMYT, we have been actively participating in AgMIP and contributing data to the working groups on, of course, maize and wheat. I would like actually to emphasize the valuable long-term collaboration between AgMIP and CIMMYT, which has been instrumental in advancing crop modeling activities across various agricultural systems, but also to advance CIMMYT's knowledge in crop modeling. A prime example of this collaboration is the partnership and the work between Matthew Reynolds and Senthold and the AgMIP wheat team through the International Wheat Yield Partnership Project modeling traits for increasing wheat grain yield. Today, we have a broader scope. We're not just about maize and wheat, but also have included dryland crops and legumes in our work. So today, we're also expanding our crop systems, disease risk, and agroeconomic modeling research and capabilities. CIMMYT, therefore, is sharing data and expert knowledge for many activities of AgMIP. And one interesting new one that is quite promising is the connection with the BNI project, the Biological Nitrification Inhibition project that we are lining up for you. You'll hear some of this from our experts in these areas during the 4-day workshop. And therefore, I hope that you will take this opportunity to build stronger connections beyond the workshop, to design ongoing collaborations and to explore new opportunities for increased impact and scaling. I want to thank you for responding this enthusiastically to the call to address the climate change emergency with state-of-the-art agricultural modeling, like I used to put it, by collaboratively developing the innovation urgently needed to solve tomorrow's problems today. I will be looking forward to learning about the conclusions you reach and about the game-changing actions and recommendations that will come out of this workshop. With this, once again, thank you for participating in this landmark event for our research community. Thank you for being with us, and once again, welcome to AgMIP10.
Great. And now we turn that. Thank you very much, Bram, for that rousing call to workshop, a call to action for the workshop. And now we turn to the co-chair of the AgMIP Steering Council, Morven McLean from Washington University in St. Louis. She's going to be on the phone, I believe, right? See, we're totally hybrid workshop. By the way, while that's coming up, while we're joining with Marvin, we want to thank all members of the AgMIP Steering Council, some of whom are here. So if you could raise your hands so we see Claudia and Ashfaq are here, and everyone else will be meeting also virtually tomorrow at lunchtime. So Marvin, are you on the line?
I am, Cynthia. I hope you can.
All right, please, over to you.
Thank you very much. Good morning to everyone in El Batan, and good morning, afternoon, and evening to all who have joined online. I'm pleased to be with you today, and my sincerest apologies for not being able to attend AgMIP10 in person. AgMIP, which turns 15 years old this year, has a network currently that stands at 1,267 member researchers from 96 countries. This clearly demonstrates the global importance of AgMIP's mandate to improve agricultural models through intentional, collaborative engagement across sectors, disciplines, and countries. In the current geopolitical climate across the world, and with science and climate change being attacked directly and indirectly by the highest levels of government in several countries, it's essential for AgMIP to continue to develop the evidence base needed across sectors to inform sound policy development and adoption. This includes data generation and interpretation, and even more emphasis on communicating about and demonstrating how AgMIP's research and work products have tangible real-world impact. This is no small task, and this global workshop could not have come at a more critical time. It's my hope that the outputs from this week's working and radical collaboration sessions, duly informed by the 6 plenaries, will lay out actionable steps for AgMIP to deliver on its mission to significantly improve agricultural models and scientific and technological capabilities for assessing the sustainability of agricultural systems. Our colleague and my steering council co-chair, Francisco Metza, is not able to join us this morning, but he asked that the following message be shared with you all. Dear colleagues and friends, I'm pleased to see you all for the 10th AgMIP. I wish you a highly productive and enjoyable meeting. Yes, I was there when AgMIP was launched with many questions in my head, but responding with the same enthusiasm as the one shown by Cynthia and the team leaders. AgMIP became my intellectual family and opened a number of opportunities and exciting projects. Yes, there is a huge gap in knowledge between crops, regions, and policy approaches to deal with challenges imposed by climate variability and change. Let's continue working to fill it and identifying new areas of work and application that need to be transferred to society. Hopefully, I will be able to see some of you in the future. For now, please receive a warm greeting. Un fuerte y sentido abrazo, Francisco. On behalf of Francisco and the other steering council members, I want to extend my sincerest gratitude to Cynthia, Alex, Eric, and Natalie for all that they do every day, and sometimes against formidable odds, to keep AgMIP relevant and moving forward. And to all of you who give of your time, expertise, and experience to this dynamic, productive, and sometimes chaotic community, thank you for supporting and contributing. And with that, I wish us all a highly productive AgMIP10. Thank you, Cynthia.
Thank you, Marvin. Thank you. It's great to see you. Yes. Now we're going to have a few words from our executive committee. This is, again, running AgMIP day to day. So we're going to hear from the folks in the room. So if could, Herman, Laura, and Anthony come up and say a few words, please.
Yeah, sure. Good morning, everyone. Anthony Whitbread from ILRI, International Livestock Research Institute. I'm based in Tanzania. I used to work for ICRISAT. I was in India for several years, and I was a professor in Germany before that. So that was a short history of my career. I've been involved in AgMIP since I joined ICRISAT in 2014, where we led much of the work on the program that was engaging in the regions. And I think that was the highlight of AgMIP for me, was this ability to move across regions and to build modeling capacity, connect to policymakers, with models, particularly around these issues of climate. So my role on the AgMIP executive has been to represent the CGIAR, particularly these centres, CIMMYT, ILRI, ICRISAT, CIAT, ICADA, and some other centres, IFPRI. We're all working on different elements of modelling, from crop kind of risk management in crop systems, through to the crop livestock modelling, through to the global economic modelling. And there's a real need for the CGIAR and AgMIP to come closer together. And we've got some opportunities to do that over the next few months with potentially some new funding that's coming through an important donor. Yeah, so my role has been to try and link the CGIAR to the AgMIP community, because in the CGIAR, we work at the interface of often policymakers, stakeholders, farmers and livestock keepers. And our scientists, while they may be modelers, they're often not really doing the full modeling that you need to do as a modeler. So we need often these connections with the AgMIP community to advance the science that we're doing. The two areas I'm trying to push in the CGIAR in terms of modeling is around this area of crop livestock and livestock in pastoral systems. This has been an area much neglected. I think livestock in general is neglected in agriculture. It receives a pretty small proportion of funding for research. And in terms of modeling, it's far behind. And connecting crops and livestock and the role of rangeland systems and how livestock interact with grazing systems is extremely important as we look forward to better sustainability in rangeland systems, restoring landscapes. And so one of the major initiatives behind this is the low data, the low input modeling group that I'm helping coordinate and involve with my colleagues from CIRAD. And so tomorrow we have a nice session, so you should come to that session. And that's very much about trying to advance the modeling of low input systems, particularly the modeling of organic matter, intercropping systems and risk. So yeah, great to see you all. Please reach out to CG colleagues and get involved in what the CG is doing. It's extremely impactful. It can take the work that you're doing that may be often desk-based or getting into papers, but not getting into practice. And I think the CGIAR can really play a big role in the application of your work. Thank you very much.
Thanks.
Thank you for lending me your mic. My name is Laure Tal. I am a research director in a West African think tank named IPAR. And the funny story is that I started, I went to a AgMIP meeting for the first time. It was in Montpellier. And at that time, I was more of an agronomist. And now, 7 years later, I am an economist. I don't know, maybe it's the hat. I like the gold one. So this shows you the diversity of the AgMIP community, but also the really dynamic atmosphere that we are living here. We can pick up new interests. We can have collaborations, and I thank Roberto and all his team for the great work that he's doing with us, IPAR in Senegal and in other countries of the global south. Today we are in this beautiful campus, a research campus, and I was talking this morning with my colleague in Senegal, and I was telling them I am on a research campus, and they were like, "Oh, poor you, doing a meeting in a research campus. You are probably in really bad conditions." And I was like, "No, in this campus, we see what research can pull out. We see that when there is interest and involvement and engagement and research can be something great. And I'd like to see this AgMIP10 workshop as a workshop for better research, for sure, but also more efficient research. And I will pick some words from Anthony. As researchers, especially as modelers, we tend to be really into the data, into the models, into the really specifics of the work we are doing every day. But we need to look at a larger horizon and see what the data, what our results can change in the world we are living in. And the nexus that AgMIP is bringing to the table in terms of results are really needed by decision makers, because what is modeling if it's not a decision-making tool? So thank you again for being here. Thank you for having me. And to you now, Herman.
To switch it on, I guess. Yes. Thank you very much. Good morning, everyone. My name is Hermann Lotzekampen. I'm from Germany. I'm at the Potsdam Institute for Climate Impact Research. I just realized today is the 1st of April, and exactly 24 years I started working at PIC on the 1st of April. And I'm also, yeah, not a joke, actually. And I'm professor at Humboldt University at Berlin. Yeah, I started with AgMIP at AgMIP2, 2011, San Antonio, and I joined the global economics team, then led by Jerry Nelson from IFPRI. And yeah, since then, we have been heavily involved with several topics at PIC. We are connecting climate with crop modeling and economic modeling. And yeah, this has been an incredible journey also to show how this works over time. As Cynthia said, I think at that time in San Antonio, we were 10 economic modeling groups meeting for the first time and setting up this group. And guess what? Yesterday we had our side session, and we are still 10 global economic modeling groups here for many years, collaborating, connecting different topics, close connection across teams with the global gridded crop modeling team, for example, co-led by Christoph Müller, also from PIC, and Jonas Jägermeier. So, you know, we have lots of things happened and connections also cross scales from the global to the national to the regional integrated assessment teams. It was also tough at times. I mean, we had steep learning curves, a lot of suffering in the beginning, you know, to bring together teams, different modeling teams, harmonizing protocols, coming up with a procedure, always with limited resources. But I think what really drives us is if you bring modelers together, you know, they can hang up on parameter discussions and elasticities, you know, for hours. If outsiders would be there, they would think, you know, these guys are crazy, but for us, it's just fun. And it just shows that, you know, the people come back and back again and learn about their own tools and improve their tools by this collaboration. So I think this is really great, and I think we all agree it's more needed than ever. And yeah, so we'll learn a lot about the different teams, what they achieved. Yesterday we had a couple of side sessions which were already interesting, and then the other sessions we are having now. But let me close in saying I think we all agree that science is important, and it's amazing what science can do, and that's more and more important than ever in these incredibly challenging times. I mean, we always can tell stories now about the challenges we are facing, and I cannot resist to tell this little story. I mean, we are here at CIMMYT, the birthplace of the Green Revolution, actually, with Norman Borlaug. And I tend to say I have a small thing in common with Norman Borlaug because I spent 1 year at the University of Minnesota as part of my PhD education, where Borlaug got his degree. And if you haven't seen it outside, there's a nice statue of Norman Borlaug, you know, with all the flags of all the countries behind. So don't miss that, because, you know, if you think about that, it's just incredible what scientific achievements, what impact they can have. Yeah, and so let's hope that we can also generate insights which have, well, something like that or similar impacts now and in the future. Thank you very much.
Great. Thank you. Thank you. Thank you to our exec-com members who are here. Also, we want to thank the ones who aren't able to be here. Senthil Desang, big shout out to Senthil. And I'm sure he's wishing us well too. Geeta Lakshmi from India, and Mario is arriving, we think, tomorrow. So Mario will be here. Thanks, everybody. All right, I think we're now going to turn to Alex Ruane, the science coordinator of AgMIP, who wasn't able to come, but he's already yesterday been on multiple of the work sessions that happened yesterday. He's going to be with us virtually, has already done that. And we want to turn to Alex now for his welcome.
Thanks, Cynthia. Hopefully you can hear me well.
Yes. Yep. Great.
All right. Well, thanks everybody for being there. I'm very sorry that I can't make it this time, but I'm going to maybe represent the large group of AgMIP participants online who are going to be participating throughout this workshop. And I'll just repeat Cynthia's call to actively engage with those of us who are connecting online. It's unfortunate that there have been travel restrictions at this time of year affecting me and affecting many others. But I think part of the resilience of AgMIP is our ability to work in different environments and across different time zones and different technologies. Before I go further, I want to thank CIMMIT for hosting, and in particular, thank Diego and Vimbai and others from CIMMIT who have been very strongly involved in the science planning and overall workshop planning for AgMIP10. And of course, we have to thank the executive committee, Cynthia, the AgMIP coordination office, Natalie and Eric, and all of those. There are several other people from Columbia and NASA in the AgMIP10 who are going to be making sure everything runs smoothly behind the scenes. So looking forward to seeing how it all goes forward. It's amazing to me that we are at AgMIP's 10th Global Workshop, about 15 years after the first one, and even further since the initial ideas were being hashed out. It's worth celebrating that AgMIP has persisted and continues to be so productive and successful after all this time. I would say that where we are and the new shape of the world makes this type of collaboration even more important. Our ability to come together, to talk science, to talk decision support, helping some of the world's most vulnerable communities and some of the most critical systems of society to be resilient and productive. Being able to do that across international borders, to be able to do that across different cultures, different stages of career, and all of those things is very, very important, and probably even more so today. We do see challenges building all around the world related to policy, related to economics, related to the environment. We see things like climate change, biodiversity, desertification, shifts in food security all around the world. That means we, again, need models to start to explore these things that have not yet been observed, but that we can see coming. We need processes to think about the storylines of what may be around the corner. And we need to be able to explore those places so we can also explore the solutions that can be proactive and reactive as the world is changing around us. We also see tremendous possibilities with new advances in science and technology. That includes ever-growing computational power, new data-driven approaches in artificial intelligence and machine learning, new remote sensing data sets coming from satellites and drones and other UAVs, as well as, generally speaking, I would say that there has been, since the first AgMIP workshop at least, a continuing increase in the recognition that the food system has many interconnected and interdependent elements. So at the root of everything that we're trying to do, however, is the fundamental understanding of agricultural systems as we draw from experimental work and have core process understanding in our models, whether they're climate or biological or economic. So we want to not only advance those models, but understand the uncertainties as we are forced to apply these models even under uncertainty, as decisions cannot always wait. Finally, I just want to encourage everybody at AgMIP10 to get outside your comfort zone. The side meetings are always fun because we get to bring together some of the AgMIP teams. But I'd encourage you here to use the opportunity to meet some people that you don't already know. Look for that interdisciplinary connection. Look to shift what you've learned for one crop species or one crop system or one economic market to another region or another discipline. Please also try to identify and confront new challenges. And remember that the bread and butter of AgMIP is our activities and our intercomparison teams. So please look for those new initiatives. Please make concrete plans and please present them at AgMIP 11. Thank you very much.
Thank you, Alex. And I see the hats in the background. Did you see the AgMIP hats in the background that we were talking about? But guess what? Tomorrow, you're all going to get new AgMIP hats before the photo that will be in front of the Norman Borlaug statue that Herman was talking about. Okay. So I think both Bram and also Alex, to a certain extent, have already presented what the workshop themes are. We will be then having around these themes plenaries, panels, and working sessions. We have lots of different kinds of, so I'm not going to read them all out. You can all find them online on the agendas, but here is what we're actually going to be doing. So AgMIP workshops are filled with all different kinds of activities. The first is the side meetings on Monday and Friday that we held yesterday, and also some on Friday. Please look and see, and if people are still going to be around, see if you would like to join any of those topics. They're from the teams, projects, emerging topics coming together. We also have paper presentations. There were about 150 submitted abstracts. So there was a lot of reviewing and organizing and putting in which one will work, et cetera, et cetera. So they have all now coalesced into culminated in over 90 presentations across 13 sessions. So please be sure, I know, and some of them are parallel, and you're going to have to be running back and forth to catch the papers that you want to see. For the posters are both in person and virtually. Do we have virtual posters also? Yeah. How do they work? Oh, okay. All right. Very good. So they're out on the porch, right? And please, first of all, for the poster presenters during coffee breaks, please go to your poster, and everyone else, please engage with the poster presenters during coffee. And I guess click on the virtual ones, and they'll be up all week. Then we have something we call radical collaboration sessions. This is what Alex exactly was talking about, and other of our speakers as well, to reach out so that there's opportunity for engagement but among different groups. So it's not just all the, let's say, the wheat maulers doing their thing, that's what happens in the working sessions. These are flexible. These are not set in stone. So I've already heard that the GGCMI, the Global Gridded Crop Modeling team, and the wheat team want to meet together this week, and the radical collaboration session is the time to do it. So we will organize. I'm looking at Eric and Natalie. We need to put that into the organization of the radical collaboration sessions. And if there are other groups who want to meet specifically, let us know. That's what it's about. And we're flexible. We have working sessions, which are the teams themselves to advance. What are the plans? Concrete plans, as Alex said, concrete plans for working together in the coming year. What protocols are you working on, and advancing them? Finally, we have our lunches. See, we use every minute. We have to take advantage. So for the 3 days, each lunch has a theme. So the first is regions. So please gather at tables with people from your region. The second, and I think we're going to have some questions on the tables for discussion, to guide some lunchtime discussion. The second one is about gender balance. Always, Gender balance is a very big deal for AgMIP. Sometimes we have special, like women in AgMIP lunches and meetings. What we do now is we all mix to completely talk over any gender issues and advance engagement across gender. Then the third one is career stages and advancement. So we have folks who have been here for a long time, as we said, with the people who raised their hands who were here from the beginning, but we also have many wonderful new young scholars and modelers. And so at the lunch tables on the third day, please join and make sure there's some of each across career stages to discuss career advancement. We're also meeting with our steering council. We had a meeting last evening, Wednesday lunch. We're having our main meeting with the steering council, getting their wise counsel on how to move forward in these challenging times. And then Thursday as a wrap up. So that's what we're doing this week. And here's another thing. At AgMIP meetings, we always have field trips on top of everything else. So thanks very much to Isabel and her team who have organized tours, because here we are in the heart of the Green Revolution. So what we're doing is in the lunches, after you talk about the topics, the last half hour of the lunches on every day, there's going to be tour leaders who will be taking all of you, the different groups, 3 different groups, to the CIMMYT Museum and the other places right here on the CIMMYT campus so that you really experience what's going on at CIMMYT and what's really happening here, and the amazing work of CIMMYT. So that's the tours, and this should be also online. Good. All right. That is it for the welcome part. And we're now going to turn to the kickoff plenary, which is on the topic of science and policy. And I want to start off, we're going to have 2 keynote talks and then a panel. So I want to start off the introduction to our first keynote speaker by saying that Manuel Otero, who is our first speaker, and I just published an article. Evidently, Il Financiero is like the Forbes or magazine of a publication of Latin America. And we wrote an article about science and innovation to feed humanity, very much the topic here, of course. Just highlighting there was in the beginning, of course, all the challenges that we've been talking about for the food system, but then we bring forward that there is so much to give that provides hope, that even as the population has grown, there is more protein in the food and calories, and there hasn't been as much expansion into natural areas that some people were, really kind of calling gloom and doom about, and also that the prices, in fact, are lower. So in terms of providing the food, affordable food for people of the world. Why is this the case? Often you hear the litany. A lot of times you don't hear the good things that are going on in food system. And a key reason we all know for these achievements is what is called the slow magic of science and technology applied to agri-food production. And that's what we are all working on night and day, not only here in an AgMIP workshop, but in our own home settings and research settings. So I turn now to introduce a longtime friend of AgMIP, Manuel Otero. He is the Director General of the Inter-American Institute for Cooperation on Agriculture, known as ICA. He's been there since 2018. He is advancing technical cooperation around the promotion of agriculture and rural development. He's been innovative in developing policy and partnerships to actually make these advances. And we want to make special mention of his work with the private sector, because it's always really, agriculture and food is always a public and private partnership. And we really are so glad that you're with us to kick off at the kickoff plenary and for really providing us with new models of cooperation. Manuel. Oh, now, do we need to get, Eric, can you explain about the translation?
Well, yeah, so
Thank you
Manuel
so
will be giving his keynote in Spanish. So if you do not speak Spanish and you got one of the headphone things, you should put it on now and you will hear the translation.
Thank you, Eric. Thank you, Cynthia. Just a few words. Yes. Okay. Just a few words in English. Congratulating all of you for participating at the 10th edition of AgMIP. And also would like to recognize Cynthia. She's AICA Goodwill Ambassador. It is a real honor for us. And it's a pleasure for being once again at CIMIT. I look forward to meet with Bram at the Nairobi meeting during the Science Week. But since Latin America and the Caribbean region is a mega diverse region, multicultural one, I'm going to speak in Spanish since 65% of the population speak Spanish. So I follow that trend. Y con su permiso, entonces voy a hablar en español. Lo que yo querría plantearles es la necesidad de una nueva narrativa en la agricultura de América Latina y el Caribe. Todos sabemos, los sistemas agroalimentarios son complejos y ese nuevo entorno requiere necesariamente de una nueva narrativa, porque son nuevos problemas, requiere una nueva generación de políticas públicas y después en el panel seguramente vamos a hablar. En todo caso, la región que yo represento tiene un enorme potencial. Hay un proceso de transformaciones en curso y tenemos que entender bien de qué se trata. Lo primero que querría enfatizar es si la narrativa existente sobre la agricultura de América Latina y el Caribe refleja lo que está pasando hoy en el mundo. Las visiones actuales y reales sobre el papel y el potencial de la agricultura en la región. Nuestra hipótesis, la hipótesis que nosotros defendemos en la agricultura, es que los nuevos escenarios necesitan tener una nueva narrativa. La agricultura en nuestra región todavía está sujeta a las políticas industrialistas de los 50 y los 60, a los conflictos agrarios, a la pobreza rural, y todo eso está cambiando. Por eso necesitamos, y es la propuesta que yo vengo a hacerles, de una nueva narrativa. Hay nuevos escenarios de ciencia y tecnología. Le piden a la agricultura que participe activamente en la transición energética. Una agricultura que además de producir más alimentos, sean más saludables. Y es obvio, revertir la tendencia de seguridad alimentaria y enfrentar, por supuesto, la crisis climática. Uno de los temas que yo querría enfatizar sobre las nuevas tendencias está relacionado con el tema que la población en América Latina, esos 660 millones de habitantes, han tenido un proceso de urbanización enorme. En 1950 era un 60% de la población que vivía en las zonas rurales y ahora tenemos, con suerte, un 20%. Somos la región del mundo que más rápidamente se ha urbanizado. Y déjenme plantear mi visión. Cada vez que un productor se va de las zonas rurales y se transforma en un consumidor, los problemas tienden a agravarse. Tienden a agravarse. Porque la pobreza se urbaniza, no encuentran nuevas fuentes de trabajo, es realmente un círculo perverso y por eso la invitación desde el ICA es a pensar en una nueva ruralidad, en ser cautamente optimistas, racionalmente optimistas sobre el rol que le cabe a la agricultura de América Latina en este nuevo escenario mundial. Ya que hablamos de cambios, quería enfatizar que durante mucho tiempo había una ecuación muy sencilla que planteaba que agricultura es igual a alimentación. Y ahora tenemos que tener en claro que la agricultura no es solo alimentación y que la agricultura debe ser entendida en el contexto de los sistemas agroalimentarios. Vean los siguientes. En el gráfico ustedes pueden ver que en los años 50 el ingreso que percibían los productores era aproximadamente un 40% del precio final y hoy es tan solo el 17%. Los eslabones vinculados a la transformación, todo lo que ocurre fuera de la tranquera, del farm gate, es cada vez más grande. Estos son datos del IRS de los Estados Unidos. Piensen lo que puede ocurrir en las zonas de la Guatemala profunda, del Paraguay profundo. Los productores están a merced de esas nuevas variables. Durante mucho tiempo comíamos lo que se producía y ahora con este nuevo enfoque de los sistemas agroalimentarios, el qué, el cuándo, el dónde y el cómo definen el espacio del consumo. Es el comercio el que tracciona la dinámica de la seguridad alimentaria. Entonces, los cambios en la demanda, en los mercados de trabajo, las costumbres sociales, hacen imprescindible una visión más amplia en la cual la agricultura, insisto, es solo una parte de los sistemas agroalimentarios. El problema es que si no damos una nueva visión, la ruralidad es un espacio cada vez más pequeño en donde tiende a perpetuarse un círculo virtuoso, en donde modelos de agricultura extensiva, en algunos casos extractiva, y esos habitantes del medio rural que no tienen acceso a la educación, a la salud, terminan yéndose a las grandes ciudades en donde los problemas se agravan. Una mega ciudad, siempre me repite el doctor Ratan Lal, también embajador de buena voluntad del ICA, es aquella de 10 millones de habitantes para arriba, en donde por día se necesitan 6.000 toneladas de alimento. Tendríamos que pensar, frente a todos estos fenómenos de urbanización, si no deberíamos también pensar en nuevos enfoques hacia la ruralidad. A ver, ok. Nosotros desde el ICA enfatizamos que los sistemas agroalimentarios no son sistemas fallidos y en esto queremos siempre ver el vaso medio lleno y no el vaso medio vacío. Es casi como tener un hijo en la familia y decirle todo lo que está haciendo mal todos los días. Y evidentemente tenemos que generar alguna esperanza, sobre todo para una región del mundo, y luego lo voy a enfatizar, que es la región exportadora neta de alimentos más grande del mundo, con todos los errores, con los problemas de agregación de valor, exportamos a pocos mercados y tenemos la mayoría de los recursos naturales. Entonces, tenemos que darle una visión de ambición a la agricultura en nuestra región y pensar que hay un proceso de transformación en marcha y que muchas cosas se están haciendo bien. Para sustentar este tema de que la agricultura o los sistemas agroalimentarios no son sistemas fallidos, recién creo que lo estaba señalando Cintia, entre 1960 y el 2023, la población mundial creció en 3.000 millones de personas, Las calorías disponibles por persona aumentaron un 31% y el consumo de proteína un 34,1%. Mientras tanto, el aumento de la superficie agrícola fue menos, fue un nuevo 9%, y en el contexto de una caída de los precios internacionales que desde 1960, 1970 a la fecha, cayeron un 14%. Y el gráfico de la derecha es para mostrar que cada vez que hubo una crisis de ámbito mundial, la agricultura respondió a la altura de las circunstancias. Y sin hacer revisionismo histórico, sí menciono el tema de la Revolución Verde, donde evidentemente, pensando en aquella época, en aquel contexto geopolítico, hubo una respuesta increíble por parte de la agricultura. Por eso nuestro reconocimiento y admiración al doctor Norman Borlaug y al papel que cumplió el CIMIT. En esa posición que algunos tienen y que por supuesto respetamos, que la agricultura es el villano de esta película, nosotros reiteramos que es parte de la solución, y cuando se habla de cambio climático, nunca tenemos que perder de vista que el 73% de las emisiones vienen de la energía fósil. Esto no significa que la energía no tenga, perdón, que la agricultura no tenga que asumir la responsabilidad de la hora actual. Claro, tiene que asumirla, pero entendiendo cuál es el peso de cada una de las responsabilidades. Y además tener presente que la agricultura es el único sector de la agricultura mundial, de la economía mundial, perdón, que tiene la posibilidad enorme de actuar como un sumidero de carbono. Entonces las nuevas tecnologías, la innovación, tienen que ir a favor de este rol esencial que tiene la agricultura en este único planeta que habitamos. Esto ustedes seguramente ya lo saben y por supuesto las cifras agregadas hay que verlas de manera muy cautelosa, pero lo que es cierto es que en nuestra región tenemos 8 de los países más megadiversos del mundo, uno de ellos es en México. Tenemos el 40% de la biodiversidad, una buena parte de los bosques que hay que preservar, una buena parte de los manglares de todo el mundo, que es el mayor sumidero de carbono global, y el 33% de agua dulce del planeta. Por eso estamos convencidos que tenemos que utilizar la ciencia, la tecnología y la innovación y para crear puentes entre la agricultura y el medio ambiente y preservar estos recursos que son fundamentales para el futuro de la humanidad. Algunas estadísticas de los sistemas agroalimentarios de la región. Ustedes verán a la izquierda que la agricultura genera un 12% de los empleos globales. Cuando fue convocada a la cumbre de los sistemas agroalimentarios, las estadísticas de Naciones Unidas hablaban de un 40%. Y estoy seguro que de vuelta en Guatemala, en Paraguay, el impacto de la agricultura en la generación de empleo es enorme. Ustedes ven a la derecha arriba que el porcentaje de la agricultura, el impacto en el GDP es de un 6,5%. Lo que les comentaba antes, las exportaciones, el impacto de las exportaciones alimentarias en el contexto de las exportaciones mundiales es de casi un 18%. Ese rol de América Latina como exportador neto supera las exportaciones netas agroalimentarias de Estados Unidos, de Canadá, de la Unión Europea, de Australia y Nueva Zelanda juntos. ¿Hay que mejorar? Por supuesto que hay que mejorar, pero siempre digo de la manera más respetuosa, recuperemos la autoestima y el valor estratégico de la agricultura de cara al futuro si es que hacemos las cosas bien. Y una cosa que tenemos que mejorar está en el centro, en rojo, que es la productividad por agricultor. Y aquí América Latina está en algo más de $7.000 por agricultor, cuando la productividad de ese mismo trabajador en los Estados Unidos supera seguramente los $40.000, en Canadá o aún en la Unión Europea. Necesitamos intensificar una agricultura, insisto, intensiva en conocimientos. Y tenemos la gran oportunidad. Claro, hablando de autocríticas, evidentemente tenemos muchos temas por corregir. En el plano social, el 40% de la población rural es pobre. Y ante la falta de oportunidades que tenemos en esa vieja ruralidad, donde los productores, los habitantes de ese medio rural no tienen acceso a salud, a educación, los ingresos, como ven ahí, de la agricultura son un 30, un 50% más bajos que en los otros sectores, es donde se perpetúa ese círculo vicioso de una agricultura extensiva que necesitamos romper para poner en marcha un círculo virtuoso de una agricultura que agrega valor, que genera empleos. Problemas ambientales, por supuesto, tenemos. Hay un 50% de tierras que están degradadas, sobre todo en las zonas, en la franja tropical, donde los suelos son más frágiles y donde tenemos mucho por hacer. Hay pérdida de diversidad genética, claro que sí. Aumento en pestes y enfermedades. A partir de la tarde voy a estar con el secretario de Agricultura de México para ver cómo ayudamos a toda la región centroamericana, a todo el continente, con una enfermedad que parecía haber sido erradicada, que es el gusano barrenador. Y ante la debilidad de los servicios veterinarios y dado que estas pestes vuelven a veces con mutaciones, necesitamos hacer esfuerzos muy grandes para volver a controlarlas. Vuelvo a repetir, la productividad por trabajador es muy baja y acá estamos frente a una gran oportunidad. Necesitamos ser optimistas y creo que... Gracias. Estamos frente a nuevos escenarios, no creo, estoy convencido, en ciencia, tecnología, innovación, que tenemos que verlo como grandes oportunidades para la transformación de los sistemas agroalimentarios. La biotecnología y la genética avanzada, la agricultura digital y de precisión, la inteligencia artificial, la agricultura regenerativa y el secuestro de carbono, la digitalización y nuevos modelos de negocios. No estoy hablando de la agricultura que se va a venir dentro de 10 años, es aquí, es ahora. Y es el futuro que tenemos que construir y que nosotros desde el ICA decimos que nos merecemos. No es el futuro que tenemos que esperar pasivamente, sino es el futuro que tenemos que construir. Todo esto está cambiando la frontera, la curva de posibilidades de la agricultura y no podemos ignorarlas. Acá es cuando chocamos con la realidad, porque la realidad es que estamos, y hablo en nombre de los países de Latinoamérica y el Caribe, estamos subinvirtiendo en ciencia e innovación, a veces con agendas superadas, porque tenemos que estar pensando en estos nuevos temas. Son agendas que únicamente dependen de los aportes públicos y tendrían que ser aportes público-privados. Y sería un error histórico si no aprovechamos para la agricultura esta nueva frontera de la ciencia, la tecnología y la innovación. Desde el ICA le damos una enorme importancia a la bioeconomía. Queremos y estamos trabajando para ser la institución referente en el continente, y para nosotros la bioeconomía es la gran oportunidad para aumentar la eficiencia, la sostenibilidad de esos sistemas. Para la transformación de las áreas rurales, la bioeconomía permite generar desarrollo in situ en los territorios rurales, generar valor agregado, mejorar nutrición y salud, contribuir a la sostenibilidad y a la resiliencia climática, algo que en Europa comenzaron hace 30 años. Nuestros países están reaccionando y el ICA tiene perfectamente mapeado los distintos estadios de evolución en cuanto al tema de bioeconomía en todos y cada uno de los países de Latinoamérica. Por eso insisto que no podemos seguir aguardando mucho más. El ICA posiblemente en mayo va a estar lanzando una propuesta sobre una nueva narrativa que de alguna manera iniciamos en la Universidad de Colombia en un evento donde estaba Cintia, había otros investigadores, estaba el presidente de Guyana, un país que a partir de los excedentes de energía fósil quiere hacer una transformación muy importante de su agricultura. Entonces, hay tres dimensiones que nosotros queremos enfatizar en torno a la nueva narrativa. Uno, de que el sector agrícola incorpore y responde a las demandas de una era, sobre todo para dar respuestas a la seguridad alimentaria y al cambio climático. Es una falta de respeto como región que generemos excedentes para alimentar 1.500 millones de habitantes y tengamos al interior del continente 131 millones de gente, de compatriotas que padecen inseguridad alimentaria. Ahora, muchos de esos problemas son problemas de la economía, de que esos trabajadores no tienen accesos económicos a esos alimentos. Segunda dimensión, es un sector que tiene que captar las oportunidades en ciencias de tecnología y la innovación. Y seguro tenemos que verlo, nuestros gobernantes tienen que verlo como un actor estratégico para las economías nacionales, ofreciendo oportunidades para el crecimiento económico y la inclusión. El ICA, no está bien que yo pase avisos comerciales del ICA. Si nosotros decimos que la agricultura tiene que transformarse, nuestras organizaciones tienen que transformarse. El ICA está en un proceso de transformación profunda, reduciendo al máximo posible la burocracia, generando respuestas a las demandas y necesidades de los países. Hay una definición de cooperación que me encanta, que viene de la raíz latina cooperatio, que es la acción y el resultado de trabajar juntos. Debemos trabajar juntos y generar respuestas a los países que con mucho esfuerzo contribuyen con sus cuotas al ICA. Y yo les puedo asegurar que en su gran mayoría están al día. Países como Haití le pagan su cuota al ICA. ¿Cómo uno puede defraudar a esos países? Tiene que honrar hasta el último centavo esos países. El ICA se ha abierto, vamos a recibir este año en la sede central 25.000 visitantes. Tenemos un centro de interpretación del mañana de la agricultura que es realmente muy visitado, el tercer laboratorio de fabricación digital de agricultura del mundo, y todo esto es con el propósito de invitarlos para que vengan y que hagan todas las críticas que quieran, pero sobre todo para que podamos trabajar juntos. Y con esto, y habiendo ahorrado a los organizadores 2 minutos, para que vean que la agricultura es parte de la solución, les quiero agradecer a todos una vez más por esta posibilidad y decir que desde el ICA estamos a disposición para seguir construyendo un nuevo futuro para la agricultura, pero todos juntos. Muchas gracias.
It's wonderful. We're now going to go to our first panel discussion, following on from Manuel's really perfect introduction to the topic of the panel, which is science policy linkages for food systems. Ghassem Asrar, former chair of our steering council, he would always say to us, you AgMIPers are the push of the science, but you need the pull of the policymakers. So could Manuel, if you could join on the chair, and Baron Orr and Kevin Pixley, and Hayden is online, coming online. And we're going to go to our discussion of the Yes, now? Can you hear me? No? Yes, good. Okay. As I said, Gossamer Rohr would say, you guys, you AgMIPers are all the push, but what about the pull? Who's pulling the work? Who wants the work? Who needs the work? How do we create these policy? How do we create actually the policy linkages for this amazing science that all the AgMIPers do? And so we have four different perspectives on this. I think we'll go to Hayden. Is Hayden online? Let's go to Hayden first. Hayden Montgomery is Program Director for Agriculture at the Global Methane Hub. Maybe he'll tell us a little bit about how Global Methane Hub was created at a recent conference of the parties. A great group of funders coming together to really make progress on methane. He has served as the special representative of the GRA, the Global Research Alliance, which some of you may know about, on agricultural greenhouse gases. And he has also involved in his original home country is New Zealand, and was involved there in domestic agricultural climate change policy. So here's, and Hayden, I know you've been listening in for a while, so you heard some of the welcomes and Manuel Otero's wonderful kickoff keynote. So over to you. For everybody gets, the panel each gets 3 to 5 minutes. I think we have a timer who's going to help us, because then I'm going to ask one question, which everybody gets 1 minute to respond to, and then we very much want to have Q&A from the audience. So here we go. Hayden, over to you. 3 to 5 minutes on your take on science policy linkages. Thank you.
Thank you, and thank you very much for the invitation. I hope you can hear me clearly. Can someone give a thumbs up just to make sure? Yep, great. And thank you, Manuel, for that keynote presentation. It's great to see you even virtually. Look, it's a great privilege to be here today, and I'm looking forward to arriving on Thursday morning to be with you in person. Quickly on the Global Methane Hub, we are a collaborative re-granter, so we have a number of philanthropic foundations, now exceeding 30, who provide their resources to us to then support action to address methane emissions from energy waste and agriculture. And we were created in the margins of the climate conference in Glasgow, which was at the end of 2021, with the signing of the Global Methane Pledge. So we are created in the political context of the Methane Pledge, but we are not the pledge itself. So I have the privilege of leading the agriculture program, and of course we are laser focused on how we can support companies and countries, all relevant actors, to address methane from agriculture in the appropriate manner. And I would just say that a lot of what Manuel mentioned resonated very much with me. I'm a very strong advocate of a sort of pragmatic and realistic, even incremental approach to addressing this climate crisis. I think sometimes the haste can get ahead of the speed. In the terms of the question, if I can, I would rather think of, instead of policy, I would rather think of how science can support decision making. I think sometimes the idea of science and policy is a little opaque and sort of general, and it maybe doesn't resonate as much with the very people we wish it to resonate with. So I'd like to think about decisions that need to be taken. And I think it would be, if I could sort of suggest how this workshop over the coming days might position itself to address the needs of decision makers, I think we should contemplate a whole range of different use cases. So what I mean is, when I say decisions, the first question is, well, what decision? And then the next would be, well, by whom? And if we are able to think of the range of different decisions that need to be made and who is making those decisions, I think it would be possible for the AgMIP community to come up with a series of clear use cases where this community is already well positioned to support those decisions that need to be taken with the existing capacity, capability of the modeling community that you represent. It would also be possible to identify which additional use cases could be addressed with improvement in the capacity and capability of the modeling community. And what would need to occur for that change in capacity or capability to occur to better support a range of different decision makers' needs. I think this would help both clarify what data or evidence is required in order to improve the models, and also to help systematize the data collection and evidence creation, which can be used by the models, of course, to give us the answers we're looking for, help answer the questions we have. If I could be specific in terms of the Global Methane Hub's interest, and this is an interest that is from my previous role in the Global Research Alliance as well, and I'm proud to say, I guess I played a small part in contributing to the MACB work and the catalyzing of funds to support that work that you undertook in Bangladesh. But I think that remains a huge priority to better understand the links between adaptation and mitigation in our agri-food systems. And to get quite specific before I let others speak, I would say one need that I see is to disaggregate greenhouse gas emissions associated with the different crop and livestock systems, and to understand how the specific greenhouse gases, and I'll be specific here, methane, nitrous oxide, and carbon fluxes within the landscape, how those different gases are changing in crop and livestock systems, and how the models that we have can best represent that, what changes would need to be made or improvements would need to be made to do that better, in order to understand the implications of changing practices on those very emissions. I think Manuel made a very good point that fossil fuels dominate CO2 emissions, quite clear, no dispute. But talking about climate impacts or climate change in aggregate terms of CO2 equivalents, I don't think is helpful to us anymore. We need to get clearer about each gas, its contribution, and understand fully the implications of the decisions we are taking on the rate of climate change. So I'll leave it there and look forward to the subsequent discussion.
Thank you, Hayden, for encouraging us all to develop use cases, almost designing a supply chain for the model results. I think that's almost what you were calling for. And then this disaggregation on the emission side. And we have some folks, and we have a session on the greenhouse gas emissions work, and that's a really good suggestion. Let's turn now to Baron Orr, who we welcome to AgMIP for the first time, who is Chief Scientist for the UN Convention to Combat Desertification, often known as UNCCD. He's also Professor Emeritus at University of Arizona and served as a NASA geospatial extension specialist. So Baron, over to you for an introduction. I know 5 minutes is very short for the very complicated policy environment that you were working on with UNCCD, but please do your best. I think you have a slide or two to guide us through. And here's the microphone.
So maybe somebody can advance the slides. Oh, for me, the next slide, please. Or maybe there's a clicker. Sorry. Next slide, please. Okay, so I'll start by letting you know that in many languages, the word soil and land is the same word. But land is much more than soil. It's also water, it's also nature, and it's people. And this convention is about all of those. And this large number, which of course changes depending on how many variables you bring into your model, is not only exhausting those soils, it's also what Manuel talked about, the conversion of land. We have to deal with both. And we have to consider land something that is limited, which has not been the approach over the years. So that's changed in this community. It's very much now about optimizing what we do where, which obviously fits this group very well. Next slide, please. It's also important to recognize that land degradation is the big story in the convention. Land degradation in dry lands, which represent a very large portion of the Earth's surface, and we're surrounded by them here, is basically land degradation in dry lands is desertification. So we're talking about water scarcity, and a lot of your work related to extreme events and also these longer term trends is very important to us. Next slide, please. And then it's also important to recognize, and this ties back to what Manuel was talking about, how do we revitalize this rural economy? How do we link it to the growing urban economy? How do we replace the resilience, or at least a small percentage of the resilience that COVID and conflict and other upheavals have caused in the global system, to do that in the more local and regional and national approaches? Next slide, please. So we're the convention that's focused on land degradation and drought resilience. Next slide. And we also, like climate change and biodiversity, have Conference of the Parties, and we had the largest one ever in December. So there's a huge momentum going forward behind what's going on in the UNCCD. Next slide, please. And it not only was large, but it was inclusive. So there were new approaches taken for local communities, for indigenous groups, for the gender balance story that was talked about earlier. And for the first time, there were policy decisions at the global level on rangelands and on agriculture. Next slide, please. Lots of science, including some people in the room. The second document there is from Peak. Next slide, please. And this ag decision, so I was asked to show what it looks like. If you look at these decisions and you find yourself, then you can leverage something that's been agreed by 196 countries. That's very important. And this group can leverage this decision on ag lands. Next slide, please. It's tied even into the science side of it. There's a paragraph, and this partners means you. So you could collaborate in addressing this decision. Next slide, please. There's another decision that looks, maybe it's tied to the idea that was presented on the methane hub, but to try and look at land at a higher level, a light in terms of mandate level, but to bring people together, so that very similar to what you're trying to do on the modeling side, but here, the entire science towards addressing land issues. Next slide, please. And that also includes paragraphs that could be tied to what we're talking about here. Next slide, please. And with that, I just want you to know that enthusiasm level in December was very high. There is no IPCC for land. Therefore, it's people like you that rally behind this and recognize that improving your land use models, harmonizing their approaches, bringing soil into the mix in a much more significant way than we have today, bringing crops of opportunity into the mix on all the crop work that you're doing will make a huge difference going forward for all three Rio conventions. Thank you.
Thank you, Baron, for bringing land, soil, land degradation, dry lands into much more, potentially much more into what AgMIP does. It's great to hear about the momentum around the CCD, and we look forward to, in the next few days while you're here, discussing where there seems to be a working group that may be forming. So please get together at the coffee breaks and the lunches and the reception and see how we can really see how we could contribute and work together on bringing AgMIP modeling into UNCCD. Next, we have our home speaker from CIMMYT. This is Kevin Pixley, who is Dryland Crops Program Director and Wheat Program Director. You have a lot of hats over there. He was formerly Genetic Resources Program, but it seems, as when we were chatting a little bit yesterday, that you're going into more interdisciplinary work, and that fits right in with the way that many of the AgMIP integrated assessment approaches with the AgMIP modeling group. So Kevin, how do you see this science policy decision-making nexus? Over to you.
Great, thanks. Well, it's a real pleasure to join this meeting, and Bram Govaerts, our Director General, requested me to please represent him when he realized he wouldn't be able to join us. Just one correction, I'm not the director of the wheat program. I was until February. Now we have Flavio Breseguelo. I don't know if he's with us in the room, but he certainly is interested in interacting with this group. So I was delighted because this is really a group that I need to work more closely with. The last two big proposals that I've been working on really need the help from this team. And so I'll be making a pitch for that, and you can watch for it, and maybe you'll find a role in one of the projects. So if we can go to the next slide, please. It's summarizing what CIMMYT is doing in the area of modeling. These slides were prepared for me by Bram, but I'm going to say what I'd like to say about them. The first one is that we've been using crop modeling for over 10 years and really using it to influence policy, using it to influence fundraising in particular, looking for opportunities, for example, for resources to breed for disease resistance. And I'll show you a nice map at the end about the potential impacts of wheat blast disease. And this has really stimulated investment from several funders. Another area in which we use it is actually documenting the potential impacts of some of our activities. In his introductory speech, Bram mentioned biological nitrification inhibition. This could have a potential to reduce by 15%, 15%, the use of nitrogenous fertilizers in wheat, but it doesn't work in all soils and in all environments. So mapping and modeling has helped us to focus on those areas where it can have the greatest impact. And the third area is really helping us to make decisions about, for example, which varieties might get advanced from advanced yield trials towards potential candidate varieties, deciding which traits in our physiology program will be used to develop new varieties. Next slide, please, talks about the case of wheat in Mexico. And these are projections using two different models and irrigated and rain-fed wheat. What you can see is that in all cases, we expect by 2050 declining yields of wheat, particularly under rain-fed conditions, and predicting a 24% decrease, predicting a decrease, but last year we found a 24% decrease in yield of wheat. I know this year it's going to be even worse because I just came from Obregón in south of Sonora, where only 20% of the irrigated land area was planted this year because of shortage of water. So if you don't even plant, then even the irrigated area is going to have tremendous reductions. Next slide, please. Also helping us to prioritize what are some of the adaptation measures that can be useful. And here you can see in this graph, both under irrigated and rain-fed conditions, some of the opportunities to influence or to ameliorate or to adapt to climate change. The one that I'll mention, only one of them is nitrogen. If you look at the graph side on the right-hand side under rain-fed conditions, surprisingly to me, although Diego was explaining it to me this morning, increased nitrogen will be probably the best way. Not only application, but perhaps through rotations having more nitrogen in the soils. Now, this is good news, but it's also bad news. We're trying to decrease the use of nitrogen in agriculture. And what this modeling is telling us is that probably the best way, at least among these chosen options, would be to increase nitrogen use. Next slide, please. We look at that map that I promised you. Those areas in deep red or orange are areas that are likely to be impacted by wheat blast disease by 2050. the most striking thing I found in this figure, it isn't the areas like Ethiopia and Brazil and southeastern United States that are going to be affected, but rather that the areas of the Indo-Gangetic plains of India and Pakistan are still in blue. I would have thought the problem is likely to be much greater than this 13% predicted decrease. And yet Diego pointed out to me, well, these are irrigated areas and this disease won't have a tremendous impact in the irrigated areas. So it really helps us to prioritize our investments in breeding activities and agronomic activities, in this case for wheat blast, but also for other diseases.
Manuel, it was wonderful to hear your keynote. We're moving on now to a kind of a rapid response from all of you. So I want to ask you, you're going to start, and here's the question. From your perspective, as AgMIP10 gets underway, what would you want to ask the AgMIP modelers? You have a captive audience here for. What are the key areas you think they should focus on? So if you could answer that, and then we'll hear briefly from our other panel members. Thank you.
Well, what a question. Thank you, Cynthia. Let me insist that we are under a new scenario with all the institutions, and we need a new narrative. We need a new generation of policies, and probably some conclusions and recommendations from AgMIP should come in the area of new generation of policies. The new generation of policies should take into account a long-term vision, intersectoral approach, which is easy to say, but very difficult to implement. Obviously, the systemic approach, production to consumer. The plain truth is that countries are facing a structural crisis, so they are just thinking in macro solutions, and they are not thinking in the new generation of policies. Let me also emphasize the virtuous circle between science and policies. This is not a symmetrical relationship, because politics can put pressure on science, defining how much money, how independent they are. So I would like to insist, it's an asymmetric relationship in which we are witnesses tensions, most of the times non-resolved, and the society, the population, pay the prices or pay the consequences. So I would like to insist in the new generation of policies. If we consider most of the countries, the agriculture secretaries are not very relevant. They are not very relevant ones, with a few exceptions. Let me emphasize the Ministerio of Agriculture of Pecuaria and Abastecimiento of Brazil. Geraldo, I'm going to say positive things about Brazil. Probably it's the only country that has followed a long-term approach. You can be supporting this idea or not, supporting a sustainable agribusiness, but they have followed a path independently of the government, putting money, beginning right now to discuss a low carbon agriculture. So agriculture is probably, Brazil is probably the exception that confirms the role that is necessary to take a long-term approach.
Thank you, Manuel. Hayden, let's turn to you. Actually, could you, for your 1-minute answer, tell about the rice modeling project that we're developing together with AgMIP and the Global Methane Hub? I think that would be great and very concrete for the participants. Thank you.
Thank you. Yes, I would like to speak to that and maybe just add one other topic as well. So on the rice topic, this is an example, I guess, of a use case, right? So as a funder and as an entity trying to catalyze funding to support the development of low methane rice, we need to know where certain approaches will work or will be applicable in the world and where they won't. And we need to know that over time under different climate scenarios. So the project that we are supporting, and in fact, the reason I'm attending later this week is to build on a previous discussion that was started in December last year in Montpellier with Sirad and Stiat and IRI and Africa Rice and various other colleagues to help define the various domains in which aerobic rice would be appropriate or even necessary in the future at a resolution, at a spatial resolution that is relevant to policymaking and decision making. And that'll help inform not only our strategy, but hopefully the strategies of governments and others and how we can address the potential for aerobic rice to play a more meaningful role in the world rice supply. The co-benefit of that would be, of course, that there are regions of the world in which rice as a flooded crop will not be viable or will come under significant stress in the future. And the current estimates of that hydric stress are, I would say, at a scale that too great to be relevant to local policymaking. So we hope we can also refine the granularity of those impact estimates on rice. And just to share like what I've learned in the recent months as I was looking into this from our vantage point, rice as a global staple is the one, I think, with the highest percentage of its production used directly as a human food. It's approaching 80%, I think, of rice production is directly consumed by humans, and that is significantly higher than maize and other staples. So we've got to get this right. We can't afford to have catastrophe in rice because it's going to be a very acute food security and insecurity problem in the future. And if I can make one more appeal with my negative time remaining,
Yes,
the area of rangelands and
ahead.
livestock, the area of rangelands, grazing lands and livestock would be also of great interest to get better, I guess, capability in the modeling community to better represent the opportunities that exist in better managing grazing lands for multiple outcomes. Okay, I think Baron mentioned a great number of those in his presentation. From our vantage point, we see significant potential to diminish methane emissions by better managing grazing lands. And it doesn't require high tech. It may use digital tools to help us, but it's very much a management practice of farmers and ranchers and livestock herders that we need to provide better information to those people in their decision making.
Thank you, Hayden. Baron, over to you for your 1-minute exhortation to the AgMIP modelers.
So over to you. How many sustainable development goals are there? 17. All of them are good. We agree?
Sure.
All of them compete for land. All of them. Where counts. And yet the direction that we're going in informing policy through science is not enough about where, but you are about where. So that's what I ask you to address. Keep in mind that SDG 15, life on land, is the least invested in SDG by far. Why? Because we cannot provide a bankable project information about the return on investment easily. Every time it's a project, it's a data issue, and you have the solution. But only if you continue this approach of developing standards so that the value add of what you're doing becomes the publication, but you make the time to ensure the fundamental is agreed across the board, so the policymakers don't have to determine, was it done right? Do you follow what I'm saying? It's a big, big challenge to policymakers. There's so much science, so many data sets. But if you ensure that that standardization process is clear and understood and where the value add comes, everybody wins. Thanks.
Great. Okay. Kevin, last word on what can we do, and in particular, what can we do together? AgMIP and CMIT.
Okay, the moment I've been waiting for. I think what I would like to do with you is less about all the threats and challenges and doom and gloom that's coming, and more about what are the opportunities and what can we do to benefit farmers. I think about cropping systems in Indonesia, where rains are coming later than ever before, and rice, maize maybe doesn't fit anymore. I think about West Africa, where it's getting hotter but wetter. And now they don't want longer maturing varieties, but they want maybe 2 or 3 crops where they used to grow 1 or only 2. And I'm thinking about the farmers in Sonora who are growing wheat and now have 20% less water to work with. And last week they told me we need options. We need to grow other things alongside, in addition to, instead of wheat. They don't know what to grow. They don't know how to grow it. They don't know what are the best options, but this community can help model those options. There's at least 50 crops that have been shown can grow in that region, but which ones have greater soil regeneration properties? Which cropping systems can contribute better to climate change resilience? Which can give greater market opportunities? These guys want to make money. All of them want to make money. So we have to also stop thinking about individual models for maize, for rice, for soybean. That's nice, but what we really need to know is for the cropping system. So I'm interested in working on modeling cropping systems, what could be the best bet opportunities and options in West Africa, in Indonesia, in Mexico, and then we can validate those and offer options to farmers that can actually help them work with climate change and not just suffer the consequences of it.
Thank you, everyone, for such great real roadmaps for us in our work. I think we have some really good ideas. And just Kevin, by the way, we have our regional farming system modelers right here in the audience. I'm looking at Roberto Valdivia. So be sure you get together, because definitely that approach with the mix of different farming enterprises is something that we've been including and doing for a long time. So listen, any questions, comments from the audience? We're over to you now. Let's see, we have some mics, and I know we've had quite a morning session. We still want to hear, we might have to hear from our breakout groups of yesterday later on in the day, because really it's over to you. What did you hear so far? And any questions for this great panel? It's been very thoughtful, I think. How about responding to those challenges? I answered one of them about Kevin's about the farming systems and this opportunity. What about the methane and rice and livestock from Hayden, the use cases? What about the land modeling that we're really being encouraged to take on from Baron and from Manuel? Really some developing, I think, Manuel, what you're encouraging us to do is really developing greater relationships of the scientists with the policymakers, so it can really be that symmetrical approach to this new generation of policies. So anything, or are we ready for coffee? Yes, Christoph Müller, yes. Okay, please say who you are and what you do.
Thanks. Okay, thanks. Christoph Müller from Potsdam Institute for Climate Impact Research. And my question is, in this science policy interface, I'm always losing it with my first sentence saying, well, there's an error bar or it depends. And then the discussion is over. but I feel very uncomfortable not saying there's an error bar, or it depends, right? So should AgMIP have a training session for scientists on how to talk to policymakers? And should we have like this pull that you mentioned in the introductory words? Like, what are really the questions being asked to science, or is policy actually asking any questions to science that we can address with our modeling? But I'm always unaware of what these questions actually are. I try to kind of do science, but this interface is not clear to me. And I think we really need to improve on that. And we need an AgMIP interface team, maybe policy interface team. And that would be helpful to me, I guess, and to many of us.
Thank you. That's a very challenging question. Let's take some other questions. We'll gather a few. I see Frank and Claudia.
Yes, Frank Ewert from the Leibniz Center of Agricultural Landscape Research in Germany. Thanks for your great input. I have a question with respect to the policymaker domain in general. That's quite heterogeneous, and it's also quite dynamic. When you want to build stable relationships, on those side of the policymakers, people change quite often. So I guess it's a challenge to build these more steady, stable interactions for co-developing solutions. That's more a statement, but maybe you have an insight on how to deal with that. My question would be, if we approach policymaker from your experience, what is more effective, to approach the legislative side or the executive side? And in some countries, you also have different levels of policymakers. You have regional policymakers, you have national policymakers. What would be more effective from that perspective as well? Thank you.
Thanks, Frank. Claudia, please.
Thank you for excellent keynote and an excellent panel. So
I'm
Claudia Ringler with the International Food Policy Research Institute. Two quick points questions. One is, I heard water everywhere, but not necessarily explicitly mentioned. And so there's also a question to AgMIP, how can we strengthen water modeling? Clearly, rice is water, right? You said flooded rice versus aerobic rice. The crop diversification challenge in Mexico is because of water scarcity. It's not because the land is too degraded, but it's obviously connected. We know in Latin America, it's drying up extremely fast. Brazil is drying up. The rest of Latin America is drying up very quickly. The tropical forests are drying up as well. So there's much more demand for irrigation now. I mean, the paper that Kevin showed that it's all rain-fed in Latin America, but actually it's rapidly irrigated areas growing rapidly. And of course, the same for land degradation. Water, soils, land are quite closely interconnected. So just if you could say a little bit about how you're bringing in water futures into your analysis. And on the science policy question that came up, I think UNCCD had recently called for, I think, applicants for the science policy interface. But unfortunately, this call closed before this event. And so I'm just wondering, could you consider liaison between AgMIP and UNCCD as part of your SPI? Thank you.
Okay, over to the panel. Baron, why don't you take Claudia's last question about the science policy interface that's just being formed right now, but also that we're going to go around and to each one of the panel members and answer whatever questions speak to you.
So let me start with that and answer maybe more than one. So yes, the answer is yes, we could connect. And that really depends on all of you. In other words, just think, for example, all the publications that you will be presenting in your PowerPoint presentations. How many of those bring it all together at a perspective level that could be given to me or Manuel or someone else to make the argument of what we need to do next? So it's two ways, right? You will have to bring numbers together that could end up in slides like Manuel showed, that bring it up to that level of decision making. But at the same time, there has to be a clarity of how do we then go through the different scales, national, regional, local, et cetera. So to finish this up, if this group decides that they would like to support the convention, we will find a way to make it linked to the SBI. Thanks.
Making a very general comparison between a scientist and a politic. A scientist is someone who is looking for knowledge. A politic is someone looking for power, for votes. And there is nothing wrong with it. Nothing wrong. No? The problem is how to translate the results of science in something that be, how do you say, eatable by a politician. So I strongly agree with your question that should have to be an interface, someone specialized in promoting the dialogue with the politics in order to understand the results and the importance of this virtuous circle. Someone is always repeating, a friend of mine, that he is optimistic about the future of science, but is somewhat skeptical about the regulations imposed by consumers. So the issue of regulation is key for the future of transforming agriculture.
Kevin, over to you. Which ones would you like to?
Well, I guess
Certainly.
I can't say too much about water, sorry to say, but about two questions about where to take the efforts in terms of policy influence. And in my experience, it's been mainly the legislative more than executive. We experienced particularly in Zambia, where we were really promoting biofortified crops. And the legislative branch, the congressmen just want to know, what is this? Help me explain it. Give me information that I can share to my constituency so they understand what this is about and what are the risks, what are the opportunities. I'm sure now with biological nitrification inhibition, how many of you in the room know exactly what that is? Probably none of us, or very few of us. So I think just being able to explain to them, but also working very much with regional banks, the African Development Bank, where we do have access to the president of the World Bank, of the African Development Bank, to the agricultural officers. Those are very keen for information, very keen for knowledge bodies, working with regional bodies like CORAF or ASARECA. They go to their governments and then convey opportunities and options. So I think those are the intervention points that I have found most useful. And as was mentioned, what legislators want is votes. So they need to be able to explain to their constituency something that will be beneficial to them so that they will want to vote for them. So understanding what they want also from your expertise.
Darren, you can just quickly say something about water, and then Hayden, you'll get the last word from the panel, and then I'll do a brief wrap up before.
I think that the answer is actually the example of Sonora that was given just a little while ago. I mean, the solutions there are not going to be limited to one sector, the way we often think about it in terms of modeling. It's going to require all of these combined. And what you have is you've got from the economics all the way to the specific crops and the effort to integrate these. Can you imagine what you could bring to the decision makers of Sonora if it was concentrated on the problem at hand?
Hayden, over to you for responding to any of the great questions from the AgMIP audience.
Thank you. There was one suggestion from the audience about the potential benefits of training scientists on communicating to policy. I would argue there's perhaps more benefit in training policymakers on how to read science and how to actually understand uncertainty, and maybe do both. But if I had to choose one, I would probably choose the other. Get the policy community a bit more educated on science. And I could assure you there are policymakers that very rarely read scientific journals. So there's got to be a way to get key information in a more kind of distilled form for those people. And I guess I might come back to my initial plea for use cases, and rather than policy, speak about decision makers and specific decisions, because to be honest, like even the question relating to policymakers, I'm asking myself, what policy? Like there could be any number of policies, and I would include in that, research foundations or science foundations have policies on what they fund and what they don't fund. So there are multiple users of this information that you can create that you might characterize in general terms as policy, but I think it disguises a lot of granularity and richness when we just use the word policy all the time. I think getting more precise about what exactly the use cases are, what decisions they need to be taken, what information is required will help us, I think, help you as a community.
Thank you. Thank you. Oh, yes. Oh, yes, please, please. Okay, great. All right, 2 more questions. That's going to be perfect timing for our coffee break.
Thanks
go
a lot.
ahead.
So my name is Ignacio Perez from the JRC, European Commission. I like a lot the approach from Baron. And to be honest, we've been facing for many years, at least in Europe, the challenge of food security. Then it moved into the Green Deal. As you know, this is now mixed a bit. So competitiveness is very important. And I think the central element of all this is land use. And I think we've heard a bit about methane, the challenge of methane, the challenge of pasture land, and how do we match these compromises of like enhancing carbon on soils, and reducing emissions from agricultural production and so on. And a lot of the activities we are doing now. So I mean, I'm leading modeling groups at the JRC, while I also contribute to very specific policy legislation, just to responding to the previous speaker, the climate law and all the legislation that we are passing has an impact assessment in the EU. So we are asked specifically to each and every of these policies to provide an impact. And I think we have a challenge here in our community, AgMIP community, to devote more time also on pasture, and move away a little bit from the classical work on crops, which are of course important, but there is much more than just producing maize and wheat. It's also producing biodiversity and producing richer soils, because part of this productivity is about saving, using well our endowments. Thanks.
Thank you for the comment. Eric, can you read the online question?
Yes. So yeah, we have a question from a colleague in India online. It's kind of a tough question, but why is it that none of the scenarios of IPCC AR6 in Working Group 3 were able to ensure food security and reduce risk of hunger? The more stringent the mitigation, the greater risk to food security. Where did we fail in linking the work of AgMIP and the agri-food security community to the IAMs?
It is a challenging question, and I'm not sure if any of the panel members really work in this area, but I'm thinking, Herman, on the Eat Lancet, isn't that now an attempt to go beyond what IPCC has done and really bring in the risk of hunger and healthy diets more explicitly? Maybe there might be perspective there.
Exactly. So maybe this needs a follow-up discussion. I'm a bit confused by the question, because actually there's a lot of linkages, and of course there are challenges with the assessment of precise number of people in the north and so on, but we have progressed a lot in the IM community, in the global econ modeling community, and in our work for the Eat Lancet Commission 2.0 now, this is this particular topic there. So I think there is a lot of work there. Maybe we need to have a follow-up discussion there.
Yes, thank you. And when Mario Herrero comes, he's going to give a presentation on the AgMIP Eat Lancet 2.0 work, which the AgMIP Global Econ team has been doing the modeling for. So we'll be catching up, and thanks to raising that question, and thanks to all of the Q&As, and thank you to the panelists, but we'll clap in a moment. Just want to say, we used to put this panel about with the policymakers and the stakeholders, decision makers at the end, at other AgMIP global workshops, but really we decided it really needs to be in the beginning as we go forward with all our working sessions and our paper presentations, etc. It's this broader context in which we do our work, and each one of the panel members has really contributed to really, I think, encourage us to think about these interfaces with the decision makers, the policy makers, with the levels of governance. I think we've gotten some really good ways of suggestions for how to go forward with our use cases, with linkage to aggregating the science up to having things be useful, which I believe actually AgMIP certainly has done with the UN Framework Convention on Climate Change, with our work being in the Summary for Policymakers. So we do know about that. But it's been, I think, a very rich discussion. So please join me in thanking the panel members. We will have our report backs from yesterday, work meetings, sessions later on. And do I need, Eric, do we need any other announcements? Poster presenters, please put up your posters and hang out by your poster. And please, everyone stop by posters and discuss the work. Eric, over to you for any further or marching orders before our coffee.
Yeah, so I think most of you have left your posters, the registration table, so they will be put up for you. If you haven't done that, you can give it to the people there and they will put them up. I'm not sure they're going to be quite ready for 11, but in all the other coffee breaks, they will be up, and yes, people can stand by them. And yeah, so we're going to coffee break until 11:30 and then immediately into working session. So we're not going to come back here. You can see there the rooms. You can choose whichever working session that sounds most interesting to you. KM10 and KM11 are right across, and also VC09. And then the KIMED open area, you go through the door over there, and then there's a library, and you can see there the seating. But yeah, so we won't meet together for a while because we're going into the working sessions, and then once you finish there at 1, there will be people guiding us towards the lunch, which is in the guest house garden, which is a little bit of a walk. So there'll be people guiding you there. And then at 2:30, well, at 2, if you're interested in this CIMIT tours, you can choose any of the 3 that were presented earlier, and you can go off from 2 to 2:30, or you can just stay and have lunch for a longer time if you want. And then at 2:30, we will be meeting back here for the next plenary.
All right. Thank you, Eric. I think we're good to go. Have a good coffee break.
Let's start. Okay, welcome everybody to our panel discussion on technology across scales, which is one of the big topics in AgMIP10. And we are very happy to have a keynote delivered to us by Geraldo, and then an excellent panel here in person on stage and also virtually that will set the background or provide some background information for the discussion then with the panel. We only have 1 hour left or we have planned for 1 hour. Actually, we have like 53 minutes left of that. So I asked everyone to be concise, both in the presentations as well as in questions being asked, so that we can dedicate as much time for questions that we all may have on the topic. So let's welcome Geraldo. Geraldo Matos is the senior researcher at the Brazilian Agricultural Research Corporation, known as Embrapa. And there he works as a digital research for bioeconomic modeling and strategic intelligence. Geraldo is an agronomist and an economist by training, which is a rare case, I guess, and has over 25 years of experience in science. He has coordinated various projects and was and is member and leader of various strategic steering bodies. Too much to mention here, so I just kind of wrap it up like that. He's also a graduate professor at the University of Campinas And as we heard this morning, he's with AgMIP from the very early days. So it's great to have you here. And we look forward to your presentation on new frontiers in technology across scales.
First of all, good afternoon. It's really a pleasure to be here. Thank you, Cynthia, the organizing committee, for this kind of invitation extending to Mbroka and myself. And the idea here is to bring some thoughts about these new frontiers in technology across the scale, this challenge topic. When I start thinking about it, do you? Okay, so the first part of the topic, new frontiers, is something related to the future, to the medium, to the long run. Makes sense, right? New frontiers. And then comes the difference when we are speaking about agriculture and we are speaking about other sectors in the economy. For example, if I have a tractor, 100% of the value of this tractor, this capital asset, is available just at the start. However, in the case of research, we have a long lag phase of research. Then we have another phase. So this knowledge, so this technology can go into practice. And then only after around 20 years is going to reach its full potential, and then it starts to decline. So this medium to long run perspective is very welcome when we are talking about agriculture, when we are talking about technology. However, when we are focusing on the long term, the higher the uncertainty, the higher is the uncertainty. Okay. It's not. Could you help me? Next one. The high on the uncertainty, the high is going to be the interest rate when evaluating that product. So that means if the interest rate is pretty high, some of the benefits are not going to be realized. So challenge out of the box projects, technologies, knowledge may eventually not go forward because of high interest rates. It's the same cash flow here, delivering completely different perspectives in economic terms. Another thing that is important, eventually when we are talking about agricultural research, this set of indicators such as net present value, internal rate of return, they are not the most appropriate ones because they will not provide a clear picture of different interest rates. Then we go to the technology component. So basically we are talking about new knowledge, new inputs or new technologies. And here comes another difference coming from agriculture when compared to other sectors. One of the difference is that knowledge and technology, they are sensitive to location. Some of the stuff could be imported, for example, from Europe and from the United States to Brazil decades ago. Others, there's no way, you need to develop, you needed to adapt. And that was the difference behind Brazilian agriculture. We were able to start putting together technology adapted to that Brazilian environment. Another thing is that conditions are going to change. Climate change, pests, water balances, and so technology may get old, may get obsolete, and then we need to change the technology. Meaning that this agricultural R&D effort must be continued to sustain agricultural productivity over time. Plus, once we have a good invention, a good product, a good knowledge, the uptake is not very quick because of the nature of agriculture. Heterogeneous, dispersed, meaning that another lag phase will be established. If nothing is done, productivity is going to be compromised over the long run. But when we are talking about technology, perhaps three big branches arise nowadays. One is advanced biology, the other is digital transformation, and the other sustainable production systems. My colleagues in these panels, they are going to be discussing more details these topics. I just want to bring a few highlights. For example, in terms of advanced biology, Embrapa has a very nice project with the University of Campinas, sponsored by FAPESP, funded by FAPESP, in which we try to mimic what's happening in a private sector company in terms of development genes and develop biological assets. But our focus is on research. So we go up to the proof of concept, and then the development and the interaction with markets go to the private sector. Another thing that is interesting, nowadays we are hearing this bio-based everywhere, bio-based products, bio-based inputs, everything you'd like to say. What is the things going on in Brazil? When you consider the major crops, and for example, the Cerrado region, what we see is that around 2/3 to 3/4 of the farmers, they are saying they are already adopting a sort of biocontrol or biofertilizers or bioproducts. By the way, since the 1970s, Embrapa is using largely biological products such as the Rhizobium that allow us to produce soybean, high levels of soybean yields without nitrogen fertilizers. So we are just in a way rebranding also what we've been doing for a long time. The same applies to digital transformation. We are now have this process. Was very well translated by this paper of Smith. Some of the things they are more easily achieved, although they do not have a big relative value. But some of the things are going to have a greater impact in terms of value, but they are also going to demand more time to be produced. This is the cycle of research within the innovation flow. And here again, another project is sponsored by FAPESP. FAPESP and Embrapa, they have this partnership in the state of São Paulo because FAPESP is a very powerful foundation to providing money, but just to researchers located in the state of São Paulo. Another thing, how is this digital transformation in Brazil and abroad? We see that Brazil is lagging a little bit behind the US in several topics, for example, in the digital agronomy, precision agriculture. But see how interesting, in terms of sustainability, Brazilian is leading the effort globally. Another thing that is interesting, when we focus on these digital technologies, again, all the crops, all the big crops in Brazil, they are already using with, for example, crops such as cotton or grains in the Cerrado region, outstanding. Another thing that's interesting to note, here in the light blue, in 2022, 42% adoption in Brazil and 68% in the US, a difference of what, 26 percentage points. In the last estimate, it was less than 20 percentage points. So Brazilian agriculture is closing very fast to American peers as well. Okay, and now we have the third branch, sustainable production systems. It was a little bit discussed this morning, but this is a system we call integrated crop livestock systems in which we can produce 365 days without irrigation. How that comes alive? You can have, for example, a first soybean cycle. Generally, it's a short soybean cycle, otherwise you compromise the other crops. You harvest this first soybean crop, and then you introduce, in this case, sorghum, but can be also corn, together with the grass crop. Why was that? In this case, brachiata is an amazing soil cover for no-till planting. So farmers adopt many times not focusing on the livestock component, but they want a soil cover to do the no-till planting. Then you harvest the crop and your pasture is already established. See, this is in the Cerrado. We have generally 4.5, 5 months a year of dry season. Look the difference, the greenness of this pasture newly established and the pastures around the site. So we gain not only in quantity, but we gain in terms of nutritive value. And then start the rainy season, start to rain again. We can use with cattle. And then we have like a 30, 40 days to decide. Would I like to continue with the cattle cycle, or I will move back to another cycle of, for example, soybean. This is from Cerrado Center, Mark. Mark was with us for how many? 4 or 5 years? Okay, and also what is nice to bring here is that those systems, they are an amazing platform that can accommodate all the other branches of technologies. One thing that is interesting to note here is that, again, when we are talking about sustainable practices, I can share all those reports with you, send the link, I think that will be interesting. But when you go to terms of sustainability practices, again, Brazil is better positioned compared to global peers, especially if you go here to no-till planting. So Brazil is trying to do all those sustainable practices put in practice. And now, how are you going to use those technologies? We can focus on a resource-saving technology, or more commonly said, land-saving technology, in which we are increasing yields. Or we could focus on a labor-saving technology in which we are sparing labor. So labor-saving technologies will focus on mechanization, automation, this kind of stuff. Resource saving is going to focus more on increasing yields. This has been very important in Brazilian agriculture. If we did a simple analysis of the land saving effects in the past decades, what we found is that if the technology was kept constant as it was in 1950, we are going to need 220 million more cropland and about 600 million hectares of pastures. We are talking about 820 million hectares of more land that would be demanded without technology, and Brazil has 150 million hectares. So basically, we are going to need another Brazil to accommodate the production in 2017. And the proof that this worked was this graph here, in which 65% of this immense territory that is about the size of continental US, 65% of the Brazilian territory is still covered with native vegetation. In biomes such as the Amazon, we are talking about 80% is still covered with native vegetation. So moving ahead, the innovation flow starts with research, we generate technology, that comes technology transfer. And Daniel is going to touch this topic a little bit. If I have just an invention without adoption, I'm not truly moving forward in the innovation flow. However, I need adoption. In the case of Brazilian agriculture, what is the difficulty? The low level of incentives. If you take the average of the past decades, Brazilian farmers receive only 3% of the gross farm receipts at the farm gate level. So these farmers, they are going to respond to market signals and they are going to adopt new practice, new technologies, if they perceive that that is going to pay off. Okay, and then comes the last part of the equation across the scales. Then we can have production scales, small farmers to more, say, large-scale farmers. Here, when we go to the labor-saving technologies, the mechanization, the area of the farm makes a huge difference. You're not going to put a big tractor in 1 hectare farm, for example. However, when we are discussing land-saving technology, fertilizer, better seeds, this theoretically is not responsive to the scale. We have the regional scale. This is a work led by the team from Purdue. This is John. And what we see here, the impacts of infrastructure is going to change all the regional production across Brazil. And this is going to be as fast as the factor mobility increases. So here we have not only the regional location that might happen, not only the production scale, but both are going to respond to this temporal scale. And once this is ready, we have summing up the result, the total factor productivity occurring in Brazilian agriculture. And this total factor productivity occurring in agriculture, they will be very important because of what they can do in terms of impacts. If I have a higher productivity, I have opportunities of reducing emissions. I have opportunities of increasing well-being. I have opportunities of decreasing food insecurity. I have opportunities to increase the multipliers across economy, such as Manuel has said this morning. So, concluding, the world is messy nowadays, and this is going to be around for a while. So we need to understand, most of our discussions this morning was what we can do, what we cannot do, what we should be modeling. Disruptions and risks are possible to occur, as the recent pandemics have shown us. Education, jobs, and rural migration, at least in the case of Brazil, they are going to continue a process. For you to have an idea. I'm finishing. Just for you to have an idea, today in Brazil, we have around 7% of the labor force is still employed in the agricultural sector. When you look to Europe, with 2.5% of the labor force, or the US, 1.5%, it's reasonable to say that the labor force in agriculture is going to shrink in the near future in Brazil. It's a process that is moving forward, and we need to be aware. Another thing that is important, and what we are doing depends a lot on fiscal issues, not only in terms of research, but in terms of eventually providing directions and incentives. And again, we have a lot of things going on nowadays. It was already challenging to get credit and financing for agricultural research, for some programs of sustainability in agriculture. Now comes all the things the big guys are discussing, for example, increase the spending in military and this kind of things. Finally, one very important premise is that if we do not understand all the dimensions of sustainability, it will be very difficult to design strategy policies, and eventually some of the things that are introduced, they might have a collateral effect that was very far from even desired in the beginning. And here comes the AgMIP approach. We need modeling in those dimensions of sustainability to try to bring some thoughts, some directions. We're not want to, hit the bullseye of the target, but we want to have some range in which the policymakers and the decision makers, they can try to make a difference. A quick example, why this is important. Actually, there was this very nice paper from 1995 from John Anto. It's called Why Scientists Should Talk to Economists. If we do not bring this economic perspective in crop modeling, that will be pretty hard. This is an example. Here, setting the price fixed, we have a biophysical model. And of course, in this other case here, the price is fluctuating. And if the price is fluctuating, the demand and supply forces are fluctuating more freely. Let's look at the land use issue that we discussed so much in this morning. In a biophysical economic model, I am superestimating what might be the impacts in terms of land use changes. It was already bad here globally. In Brazil, it was desperate. However, if we connect the biophysical with the economic model, we have a better perspective of the real world. And what we find is that actually land use changes would be much smaller than previously expected using only biophysical models, because yields are promptly responding to those economic stimulus. And this is going to be my last slide. Multiple approaches and challenges. We need to put a lot of pieces together from technology, their technology transfer, improving infrastructure. Here, I'm not talking only, for example, roads, railroads. We are talking about digital transformation. We do need desperately digital infrastructure. But despite all those challenges, I do believe that we have a future with many opportunities, but we need to try to bring some nicer thoughts on that. That's it. Thank you very much.
Thanks so much. I would now like to ask the panelists on stage. So Daniel, Frank, Yanis, and you get your notebook and then join us on stage. We have a fourth panelist online, Sarah. I'm not sure if she's already online. And we start our panel discussion with short introductions by each panelist. And we start with Daniel Mason Cross from Cornell University, where he's a senior research associate. And he's also a PhD candidate in agriculture economics and rural policy at Wageningen University. He has previously worked in CSIRO, the Australian Science Agency, and the IFPRI, the International Food Policy Research Institute. And his scientific work mostly focuses on anticipatory governance of food systems, informing policy, and to achieve a more sustainable, resilient, healthy, and just food system. That's a big bite. And he has contributed to the IPBES and the IPCC reports. And in AgMIP, Daniel is a member of the Globe Econ team. And yeah, oh, Eric disappeared. Eric was waving warnings, but oh, you're doing the, okay, great. The warnings are here. Keep an eye on the warnings. 3 to 5 minutes.
Okay. Yeah, well, thank you for that introduction. I might have given you a shorter bio if I knew you're going to read it out loud. I think, well, there's so many things to think about from the presentation that Geraldo just gave. And I think I'll focus on a couple of ones that kind of struck a chord with me and that with some of the work that I've been doing. One of them, which I think is really important, is that idea of sort of connecting the biophysical with the economics. So much of what we look at in terms of unintended consequences come from what happens when technologies are adopted at scale and how that happens. And so often we see when we look at just estimates of what might be the consequences of a technology, they're always overly optimistic. They don't consider the challenges of achieving scale. They don't consider the possible of rebound effects. So things like Jevons paradox, where, you know, by decreasing the cost of something, you might actually increase demand. And so there's a lot of importance then of being able to look at how these types of feedbacks can play out and whether or not you end up getting the types of benefits you want. We've seen this very thing when we were looking at some of the work we've done as a part of the Lancet Commission. And we saw the real importance of what happens when there's also interventions or changes on the demand side. So once you have sort of more of a control so that you don't get some of those rebound effects, then all of a sudden you start to see much larger benefits on the environment. When we ran scenarios with just productivity increases, essentially what we saw were prices went down, demand went up. We didn't get much of a benefit on the environment side, unless there was something there that sort of was a protection against that rebound effect. So I think that's a really critical thing for us to think about when we're trying to model technologies and innovations, that we think about sort of like what is their technical potential, but then a little bit of nuance on what happens when they go to scale. Another thing I thought that was really interesting in the presentation that Geraldo just gave was also this kind of long time lag. And I think this is also one of those things with trying to model or to represent changes in technology. We have all sorts of issues in terms of representing how these things are dynamic over time. So, you know, what is the timescale we're looking at for the impact of the technology? How long will it last before it becomes obsolete? How is it competing with other options? And so obviously when we're doing just a single technology, we don't always capture all of these types of competing technologies and the consequences of these things. But as we try to think about how do we model adoption, adaptation, and diffusion, it really becomes important because we don't operate in a space where there's just one technology at a time. There's bundles of technologies that are out there. They're competing with each other. They have different benefits, different drawbacks. And then thinking about how those combinations ultimately are implemented will depend then on what are the environmental, health, economic consequences of those technologies. So I think that for us, the challenge is how do we try to do that in some way that's manageable, but in many ways, I think that's what makes this area so exciting, is that there's so many questions, so there's so many angles that we can come at it from. So I guess I'll hand it over to the next person to discuss, and we can, anytime I save, can go for questions.
Excellent. Thanks so much. And for next, we have Frank Ebert, from the Scientific Director of the Leibniz Center for Agricultural Landscape Research, SALV, and Professor of Crop Science at the University of Bonn, both Germany. And Frank has a long-standing science experience in modeling crop systems in the context of climate change, food security, and sustainable intensification. He has also been member and chair of many international and national advisory boards, again, too many to name them here. And with SALV, he has just been very successful in acquiring large and permanent institutional funding to establish an innovation center for agricultural systems transformation. And at AgMIP, he co-leads the AgMIP wheat team and has worked on scaling and aggregation.
Thanks very much. Also, thanks, Geraldo, for the great overview. And I want to echo a couple of points and add perhaps one or two other points. Perhaps we can have a look at the first slides. I have two slides. No, the second. I have no control about the slides. Yes. The first point I want to make, and I also like the presentation in that context because it sort of pointed to that already, that when we talk about innovation and technology, there's not only one technology or one innovation. There's a set of innovations, and some of them have been presented, but there are many, many more. And we have to think about how we ideally or practically can integrate these different innovations effectively at the level at which we are working at. So that's, I think, an important point to be aware of the different types of innovations. It's not only end-of-pipe technologies, it's also innovation at the production system level, at the landscape level, it's innovation at the governance level, institutional level, and ideally these go hand in hand. That's easier said than done, but if we fail, and we have many examples where things didn't work out, where we thought we have nice technological development that never made it into a practical innovation. Point one. The second point, and it also sort of shined through the presentation, is the regional context, which is very important. Innovations in one region that work in one region may not be relevant or may not work at all in a different region. And that really puts an emphasis on the regional context and on the systems and the social cultural conditions, the agroecologies that are relevant in a specific region in terms of what innovations are will find their way and what is the demand for technological development and innovation. And my third point refers to more or less to our community and our engagement in that process. And that would be the link to the next slide. If you can have a move over to that slide, is how do we actually engage into that process? At the very left panel, that's the way we presently work, how we do generate knowledge, insights, and then we think about how we transfer that into practice, to policymakers, etc. But we believe at SALV, but also in other places, that a different approach is needed here. And a living lab approach, it's not something that emerged out of agriculture, came out of a different domain, is quite helpful in that context, in the sense that it engages scientists right from the beginning in the process of generating knowledge and also co-designing technologies and innovation, in order then to, right from the beginning, understand the demands and then make sure that those developments are also adopted by the practitioners, and also in the context of the policies can help to set the frame in order to make these eventually successful. Thank you very much.
Thank you. And we continue with Yannis Athanasiadis. I'm messing up the names, I'm sorry.
That's okay.
He's chair of artificial intelligence at Wageningen University and Research, and he aims at advancing artificial intelligence
to address global challenges related to food security, agriculture, and ecology, tailoring these artificial intelligence systems to help farmers, policymakers, and stakeholders by making better informed decisions and understanding complex systems better. And in AgMIP, he leads AgML, focusing on the interface between machine learning and agricultural modeling.
Thank you very much. Thank you very much for your keynote, Geraldo. I think you summarized very well what is the state of the art today. I don't have a lot to add, just a couple of points related to digital innovation in agriculture. There is a lot of promises and a lot of hype and opportunity these days. And for many of us or many of you, I don't know if you consider me a crop modeler, part of the art of crop modeling was to use a computer. Now we are moving into an era that everyone will be able to program a computer. And that is changing fundamentally how humans interact with IT. A lot of barriers in terms of programming languages, databases, all the skills of the trade that we had to learn, it will go away. We will be able to interact with computers directly, and we see a lot of added value also coming into agriculture in terms of large language models that can translate agricultural extension in local languages in sub-Saharan Africa and elsewhere. But if we go into the core that has to do with advancing our understanding and innovating at an agricultural systems level, I totally agree also with Frank. We need a systems approach at the regional level, but that also requires a lot of and different types of data to come together. And there we have an orphan, and the orphan is agricultural data. Because for remote sensing data, we have very clear players that collect them, organize them, and make them available. Either that is ESA or NASA and so on. The same thing for meteorological data. But when it goes into agricultural, agronomic data, these are largely not available. And that is a limiting factor for developing a digital component in these innovation ecosystems. At the same time, some companies, either big IT or big ag companies, try to move very fast into this innovation cycle. And what I have seen is investing a lot, and then as fast as they invest, equally fast they disinvest, because they expect to get very high gains very fast. But these solutions don't scale up in agriculture, and that leaves a gap in terms of data and information. And how to close this gap, I think that's a more fundamental problem for our community. Maybe one last point has to do with the hype. Because AI is a hype and a lot is expected from it, we need to follow a scientific approach. We need to benchmark it. And we need to leave space there for advanced, sophisticated solutions to fail and say, well, we use a very advanced machine learning, deep learning model for a task, but it doesn't improve our results. This doesn't look like it is the case still. We're all excited with the new tools, but we need to have a very clear way how to measure progress. And that could be different. It's different for a scientist, different for a policymaker, different for a breeder. That's it. Thank you.
Thank you. And finally, we take a tiny step towards our self-proclaimed gender balance and welcome Sarah Garland, who is the founder and executive director of the Triple Helix Institute for Agriculture, Climate and Society, a nonprofit dedicated to building cross-sector awareness and engagement around AgTech for climate action. Sarah is fascinated by genetics, plant genetics, ever since her bachelor, and received a PhD in plant sciences from the University of Cambridge, and has focused on the cutting edge field of CRISPR gene editing in plants.
She has subsequently worked at Columbia University and on the role of crop biotechnology in developing nutritious and climate resilient agriculture systems. Sarah has been in contact with AgMIP for also quite some time, and we look forward to your contribution.
Hi, can you hear me?
Very well.
Great. I know I'm really huge there, so thank you for having me here. I was going to wear my little green AgMIP hat, but I left it. I left it in the wrong state. But I'm really excited to be part of the conference, even though I can't attend in person. When I was asked to talk about crop biotechnology across scales, there were so many potential scales to discuss. But today I'll focus on 3, and I think they resonate well with what the other speakers said, but I'll just focus it on biotechnology specifically. So the first is the scale of technological change. Unlike most conventional breeding, crop biotechnology, like gene editing or transgenics, can enable jumps in the efficacy of important traits like disease resistance or resilience to climate shocks instead of incremental progress. For example, instead of a crop just surviving a disease a little bit better through lengthy breeding programs, we can engineer the crop to be almost entirely resistant to a disease, completely shifting the yield outcome by switching a seed. Right now, I think we're really on a precipice of the jumps that biotechnology can achieve. And of course, it is due to improvements in the technology itself, but also because of other enabling tools that are becoming more and more available. And I heard some of the other panelists mention that as well, that any innovation is not emerging by itself. We have all of these combinations of technologies that we need to look at. You're all at Summit today, so think about the Green Revolution. It wasn't only the improved seeds that yielded the results that we're all familiar with, it was also innovation in fertilizers and irrigation that enabled this technological jump. Today, some of those supporting innovations for effective biotechnology include better data-driven analysis of crop genomes, better sequencing technologies, and of course, biological inputs, which was also mentioned earlier. So breaking down the silos in between these types of tools and better predicting the interaction between them in different scenarios would be meaningful for developing successful and responsible implementation strategies. So the second scale is time. I know I just talked about innovation jumps that biotechnology can facilitate, but in reality, biology takes a lot of time. As much as it is sometimes communicated that we can do things overnight, and that kind of comes back to this hype that the other panelists have talked about, we can't really just snap our fingers and gene edit something tomorrow. We need a lot of fundamental research before that can happen, like developing well-annotated genomes and good methods for specific crop species. And then even with the best predictive tools, we still have to grow the plants, do field trials, and of course, get regulatory approvals. So the point I'd like to make from the time side is that decisions about biotechnology that we want to use in the future need to be made as soon as possible. And that's decisions all the way from the lab, like what we're going to study and what crops we want to focus on, all the way through to regulatory environments in different parts of the world. And then the third topic of scale I want to address has also kind of been brought up by the other panelists. It's about connecting different types of scales. For me, that's molecular and systemic. So to really have efficient, high throughput impact in biotechnology, we need to accelerate work around connecting the rapidly growing space of genomic data analysis and the data around environmental factors. Because as any technology in agriculture isn't just about showing it can work in the lab or one field trial, but finding how we can effectively apply technology to local and regional needs. Of course, I'll throw a final little scale in there as well, because it was mentioned earlier too, local and regional needs and at different farm scales. So there are definitely a lot of different scales we can talk about. And yeah, I hope you're considering biotechnology as an important innovation to be considering in your models. So thank you, and I'm looking forward to the discussion.
Thank you so much. I have one starting question to the panel where you basically then can just quick answer everyone, and then the question is, the floor is open to
to all of us to ask questions. My question would be, if we had an innovation modeling group in AgMIP, what would be the starting point for that? Like what innovation regime would be the starting point to pull in the other technologies that are kind of forming the package then? And what would be the appropriate scale for the innovation group in AgMIP? Geraldo, maybe you start because you had the longest pause.
Yeah, I can start. I think one of the gaps is to bring farmer into the innovation process, right? We're talking about new seeds, new fertilizers, a lot of new stuff. But the guy doing all that thing is the farmer. So I think how could we better model the way farmers is making his or her decision? If you are talking about innovation, there is no innovation without adoption. So it's not only a matter of bring technology available, bring the economic perspective available, but the decision maker, how could we model that? How this farmer is going to perceive the risks in terms of adoption. So I think this is one of the challenges for this modeling group on innovation.
Thanks. Frank, you want to continue?
Yes, following up on what Geraldo said, I'm not sure you can ask the question in that way, because there's almost an intrinsic contradiction in the question by asking for an innovation modeling group, because innovation, in the sense we have discussed it, is, as you just sort of reproduced it yourself, is a co-development process. It's a process, or can be, should be, as a process that needs also practitioners, because only then it becomes an innovation if practitioners really use it and adopt it in the field. So I would ask the question, what would we do if we had an innovation management group rather than an innovation modeling group? Because I think that is really what we need, and what we lack is how do we engage with these actors, the farmers, the policymakers, and what can we bring to the table, and how do we manage our contribution so that we eventually arrive at innovations that are meaningful and helpful.
Okay, any other answer? Daniel?
Yeah, I mean, I agree with what Geraldo and Frank just said. One thing I would add on that is, if we were to do something like that, we need to start thinking first of who we're trying to talk to about this. Because if we're talking to farmers, it would be a very different answer than if we're thinking about how do we inform investment portfolios and research for Ministry of Agriculture, right? Because if we're talking to the Minister of Agriculture, we probably don't want to be talking about individual technologies, because we don't have a very good way of predicting which ones will or won't be adopted. So then you want something that's a little bit more generic in terms of thinking, well, you need to invest in a broad range of research objects with the goal of achieving X, Y, and Z things. And this is what we think you would need to do. But if we want to start talking about, specifically what would be the consequences of agroforestry, or what would be the consequences of a new transgenic variety of maize, well, that's a very different question, and the way that we would approach that would also be different. So I think we would need to think about if we're going to try to answer all of those, or if there's some that we'll focus on first and engage with that. And so that's just one thing, just given that the scale of the challenge, we'd use different tools and approaches to answer those questions differently.
I was just going to kind of agree with what was just said, was that I think what would be most useful in decision making is having a range of outcomes and leave it not prescriptive to what types of technologies can be used, because the second you build that, it's out of date tomorrow. And so I think being able to have the ability to say, if we could decrease water use by this much, and then whether that's through a drought tolerant plant or an improvement in irrigation systems, it doesn't matter. We've achieved it that way. But then of course, if you are looking at the trade-offs for certain types of technologies, like Daniel just said, I think it would have to be, what question are we actually focused on?
Thanks. Janis, you want to go next?
Yes. I would suggest that we are not able to do that also because we miss not only farmers, but also entrepreneurs in the audience. So we need to organize it at a different level with different stakeholders and different participants. But if we look into research and what kind of research agenda we may need, I think we need to turn it around. So instead of pushing our own technologies or scientific, to see what is the, to follow a more use-inspired approach. So what is the moonshot vision we have, moonshot application? What is the major challenge? And then try to go backwards from that into what kind of technological elements we need to develop. But I wouldn't call that innovation necessarily in terms of being applied directly. Yeah.
Okay. Frank, there's a final.
Very quick. I think what we can do is to be prepared for the range of issues that may come up. Have a flexibility and a capability in terms of the tools and the data that we have to be ready to engage, to address the demands that come up. Maybe to also bring in ideas, of course, but not stick to those ideas and push them through. I'm not sure that's the right way, but to be available with a range of expertises and capabilities, tools, data, that could be a good contribution.
Fast response science. Okay. Questions? Ignacio.
Thanks a lot, and Geraldo, I liked a lot your presentation. I mean, we've been doing in Europe quite a lot of work on technology adoption, adoption of management practices. I guess the important thing here is that a farmer will only adopt technology if it makes sense, money. So if you calibrate adoption curves, we do that. We do model this at the member state level and the regional level, and include endogenous adoption as part of the modeling system. You can only trigger that through subsidies or through restrictions. Obviously, if a farmer will do conservation, soil conservation, if he has to pay a penalty or if he reduces a subsidy to do that. So we do carry survey studies. We did this for precision farming. We have done this for winter cover crops as well, to parameterize those adoption curves. So I think there is at least in the global economic group of AgMIP, there is already quite some work on technology adoption, and most of the Globecon models do have technology adoption as part of this in a more explicit or a more kind of rough way, but they do include it. Again, Brazil developing a very efficient livestock system. Obviously, this has inherent changes in the technology. If we do model a situation in which you are constraining part of the world, the production, and this production moves somewhere else, this changes the system. So this triggers also adoption of technology.
Jonas, you go next.
So we're collecting questions? Okay. Yeah, hi, Jonas Jägermeier, Columbia University. My question is around how do we model innovation or human ingenuity, if you want to? More specifically, I'm really happy to see Sarah pitch the need of crop breeding, gene editing, and that's something where we have a lot of room in AgMIP to engage in. And I've been thinking about this a lot lately. And really concretely, how do we get those things into the models? How do we model innovation? How do we expect jumps? How do we provide guardrails for gene editing? Is something I would love to engage in and would love to see more in AgMIP. Thanks.
Herman?
Yeah, thanks. Very good inputs on these different domains. Also, thank you, Geraldo and Frank, for your inputs here. I would like to challenge you a bit. If you think about the challenges ahead, right, over the next 25, 30 years, in terms of either doing nothing about climate change and facing all the impacts, or, you know, really going to net zero emissions by mid-century, and all the other dimensions we are talking about, is it really enough? You know, I'm a techno optimist generally, but the mechanisms you described, do you think this is sufficient, or do we need to change tech? We will not be in the same situation. And you can look at the scenarios we have run for many years now in the IAM community and also for eLancet. The changes across or along the agri-food systems are really huge to reach those targets. So, from your perspectives, these different elements, is it enough, or do we, accelerate those processes?
Okay, let's have a round of answers. Sarah, you have to wave with us if you want to answer. And but as you're not waving, maybe Frank, you're itchy. Oh, you're now waving. Sarah, go ahead, please.
I can answer Jonas's question since it was more directed to the gene editing side. It's really hard to know when you're just starting to do any kind of biotechnology effort how much something is going to react, like how much improved a trait will be at the end. And kind of as I was mentioning, like we can, identify the genes involved in certain processes, but then, what soil it's grown in, what exact variety it's in, those are all big challenges. So I think what would be helpful is, being able to say if we had, 30%, we've all seen different types of scenarios in a model, the high efficiency scenario, the medium efficiency scenario, and the low efficiency scenario. And I think maybe being able to explain, how much impact a certain seed trait would even have. Because as we mentioned on the panel, maybe some problems aren't going to be solved with a seed if the underlying issue is still there. And so I think that would maybe help direct the innovation as well. It's obviously a costly and time-consuming type of innovation. And then, of course, kind of to what Daniel was saying in terms of rebound effects and everything, I think that's something that could be really helpful to look into before we have a seed that's ready to be put in the ground, and think about what kinds of policies for the exact specific trait. I think he was probably referring more to yield efficiency. There are other types of efficiencies that could also have rebound effects, and being able to know about that and be able to mitigate potential issues before they're arising in the field would be helpful.
Thanks. Daniel, you're moving.
Well, so maybe responding to Jonas's comment first, I think it really depends at kind of what level or stage you are with sort of trying to think about the consequences of a potential novel idea, right? So if you're starting something really, really early before it's really even been tested on the field or piloted somewhere, you can still start doing scenarios of exploration where you can start thinking of the thought exercise of what would happen of this. You don't even need to have a model. You can do this with stakeholders where you just start having them think about, well, what would be the consequences if something like this happened? What might be some of the unexpected, reactions to this? And you could start to get a sense of like where there might be red flags of things that you might need to be looking at when you start trying to develop it further. And as those those technologies start to become better understood in terms of what their potential is for delivering positive and negative consequences, then you can start to try to model those in greater detail. And so, for example, we tried doing a little bit of this when we helped inform the agri-food system technology innovation outlook for FAO, where we were trying to think about that there's different stages and there's different applications of foresight that can use to start to try to inform this. And the more information, the closer it is to being implemented, then the more detailed that you can be with some of that kind of innovation. And I think it's good to start thinking about those things early on, because then you can start raising red flags of things that might be consequences that you want to avoid. And also recognizing that in general, we're never in a space where we only have one objective. So it's a multiple objective, multiple criteria space. And so, technology might be really strong on delivering in one aspect, but it may not help on other aspects that we care about. And then trying to think about what are complementary technologies, complementary institutions, and things like that are needed then to ensure that we get kind of a net positive. So I think there's different interventions at different parts of that process. And I guess to Erman's question, I I guess I'm also techno-optimist in the long run. I'm a lot less optimistic in the short run that we'll say achieve net zero by 2050 or other things like that. But I think it highlights the really importance of start thinking about these things as provisioning systems instead of thinking of like as individual technologies, that we should be caring about what are the outcomes the food system's providing, and then trying to do ensuring that institutions and regulations and incentives are encouraging innovation that go towards the objectives we want, as opposed to focusing on individual technologies.
Thanks. Final sentence from the last, the remaining three panelists on three questions.
Final sentence?
One sentence.
On three questions?
Yes.
Oh, that's very challenging. That needs innovation. I think, starting with Jonas, I think we are quite well able already to simulate with models single technologies with respect to different scenarios on a limited set of variables. So with respect to the impact on the limited set of variables. What we are less good at is to look at a combination of technologies like look at the genetics, look at the digitalization, look at improved cropping systems on a range of impact variables. With not only with respect to food security related variables, but also with respect to other sustainability variables. That's much more of a challenge, and that's something that we can work about. With respect to the time frame and the speed, I share the observation and the concern that Hermann made. I think it's less, my impression is less an issue of the knowledge that we have than rather of bringing that knowledge where it is needed. I guess that is the bigger bottleneck, at least from my perspective, than generating more knowledge about it. The issues that we can sort of develop or where we see potential. Thank you.
Excellent sentence. Thanks. Jonas.
Yes. I think a very important thing is the interaction across scales. So bringing in genetics or even lower scales is very, very important and relevant. But then for the technology, let's say, adoption in the future and the impact, I don't know if we can model it, because if we look into technological transformations in the past 50 years, I think most of them happened because of a lot of things happening at the same time. And I think that's something it's very difficult to predict, either at least in the digital space. Either that is AI or the internet or all these kind of things. And I think the same holds for the green revolution. So there is a randomness effect there that I don't think we can predict. That's my feeling there. Did I miss something? No.
You did excellent. Thanks. Gerardo, will you take us home?
German style plugging a bunch of words together. Okay, I think it goes more or less in line with Ignacio and Herman. I think we need to understand this interface between the generation of technology, that is a problem of the research, and the adoption of technology. For example, we talk about the success of new tillage adoption in Brazil, but the farmers, they start to adopt no-till planting, not because of the environment, but because it was operationally smart. They can plant faster. They can have 2 crops per year, sometimes 3. And then comes the other thing, brings also carbon to the soil, very good to us. So it was not a matter of the environmental dimension, it's a matter of the operational dimension. Exactly. And then you go to the profit thing. The guys received 3%, 2.5% in the past few years. Are you going to impose a tax on the guy? He said, come on, what do you want me to do? And then comes the other part, more related to the urgency, Herman. I think this is the challenge. These guys, they need perhaps to understand better what's going on, but we need to understand better their perspective as well. What is their premium risk? For example, you have a very sustainable technology that will return 12%, and the guy is earning 3% of an interest rate of return. And the guy is not adopting that. What is the demand for capital this guy need? What is the demand for technical assistance? What is the risk premium? Eventually the guy said, for me to take that risk, I need to have at least 15%. So things like that. And that might speed or not. And here comes the other very quick point, is that the poorer the farmer, the highest is the interest rate. This guy is not going to adopt a thing that is going to bring the benefits, you know, in 5, 6, 10 years. The guy wants to solve his or her problem now. Well, I will stop here because he's already mad with me. So thank you, Christoph.
A big hand for all our speakers. We started 7 minutes late, we ended 7 minutes late, so thanks for being concise and on time. We now have a coffee break where you are supposed to go with your coffee mug to posters, and the poster presenters are supposed to be after grabbing a coffee at the posters, and then we will have the paper presentation session at 4. Thanks.
Yeah, thanks for stuff. Just quickly, so yeah, it's on the screen, so you can find, if obviously you're presenting in one of the sessions, you should go there. Otherwise, just go to whichever session you want to do. Also, there's 8 of the translation thing is missing. So if you still have yours, please return it to the registration desk. And sorry, and immediately following, so yeah, you'll be at your presentation sessions 4 to 5:30. And then at 6, we will have the reception in the same location where we had the lunch.